Welcome, everyone. Today is going to be our first day of the AWS Certified Solution Architect Associate 2023. My name is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers, and I'm thrilled to be with you today. We are going to cover the AWS Solution Architect certification. This is a free, full AWS full course tutorial. And this is free AWS certification and a free AWS certification course online. I want to welcome you to this free AWS course and make sure you have a ton of fun and learn so many things. And if you desire a cloud architect career or a cloud engineering career, a lot of what we're going to cover is going to help you. Now, we're going to run this course a little differently than most, and we're going to do it for a reason. I've been an architect now for 25 years, and I've interviewed thousands upon thousands upon thousands of people. And it's always easy to find someone that knows how to configure, but it's near impossible to find someone that actually understands what they're configuring, understands how the technology works, and truly understands system design. And I want you to be the best in the world, and that's why we're doing this, and we're doing this completely free. So a couple things I want you to know. Please download the completely free AWS Certified Solution Architect Associate and Professional ebook. The link is in the description below. Of course, my team will also pop it in the chat box. While we're at it, please join me on Thursday for the completely free How to Get Your First Cloud Architect Job webinar. And why not join us on the Head in the Cloud shows tonight, where we're going to talk about how to interview in a challenging economy. So many things for you to help you in your career. Now, please follow me on LinkedIn. We have got about 5 or 6 incredible resources to share with you. Everything from how to win the interview. And we've got some exciting new free content coming for you next week, and I can't wait to share it. So follow us on LinkedIn. And we're going to have a lot of fun today. The format for today is going to be as follows. We're going to speak for approximately 20 minutes, and then we're going to answer questions for 10. Now, my team is going to be aggregating the questions because there's almost 750 people here right now, and we won't be able to answer all questions. So what they're going to do is look for common themes on the questions. And we're going to answer as many as we possibly can because I want you to have the best technology career. And whether you desire to be a cloud architect or a cloud engineer, knowing what's going on under the hood, so to speak, understanding the actual technology is key and critical to design, which we cloud architects do. And for the cloud engineers who build the systems and need performance tuning, it's not just the name of a service and how to configure it. They need to know what things are being done. So they know how to advise the architects on which things to include, as well as performance tune, because it's a team. Cloud architects, cloud engineers, they work together. And it's been an incredible experience for the last 25 years in my architecture career. Behind the scenes, we have Chris Johnson. He's my chief operating officer. We've got Alonzo Coleman, and we've got Eddie, who's over there in Cameroon. I'm pretty sure we've got Tyrone, who's joining us from Cape Town, South Africa. And we've got several other members from my team, and they're all here to help you build your best career. So without further ado, let's stop. Before we get into the context, please give me a hashtag so I know you're awake, alert, and oriented, like we medical people say. Give me a hashtag, AWS Solution Architect Certification. So that way I know you're here, and I know you're going to be able to win, because I want to know you're awake and you're hearing everything we're saying. So AWS Solution Architect Certification. And we're going to have lots and lots and lots of fun. So waiting to see that you're there. Welcome from California. I'm in South Florida. Welcome, Lady Godiva. It's really good to see you. I'm loving this AWS Solution Architect Certification, AWS Solution Architect Certification. Thank you, Rohan. Thank you, Leo, over there in Brazil, who's also part of my team, AWS Solution Architect Certification. And Claudia Smith, AWS Solution Architect Certification. And James Moorman, AWS Solution Architect Certification. I love this. I know you're awake. I know you're here. And also, when you're done telling us the AWS Solution Architect Certification, please tell me where you're from in the chat box. I love knowing these things. I'm from Greece, but I live in South Florida. And we're all over the world, at least my team. So let's get into some fun content. Let's learn, because I love learning. So we're going to, as I mentioned, we're going to cover the concepts in depth. Now, we also have some labs that you can do on your own time. And you can download them. The link for the free labs is also in the description below, which gives us more time, 3 to 4 hours each day, to really focus on the content and the depth and understanding so you can have a wonderful, wonderful, wonderful career. So let's begin. We're going to begin with the AWS Cloud and how it's organized. Because as you're designing semi-high availability architectures, and you can only design a true high availability architecture across multiple clouds, whether they be hybrid clouds or multiple public clouds. But as you want to do moderately high availability systems on a single cloud, we're going to talk about that. And that means you need to know how the cloud is organized. So we're going to talk about regions, which are basically a huge geographic area. And I'm going to show it to you visually. And we're going to talk about availability zones, which are data centers. And we can talk about what they are for a moment or two. We'll talk about local zones and why they exist. And we'll talk about edge locations. So we'll get through this. Now, I first want to begin with the AWS Cloud and how it's organized. And I want to talk about regions and availability zones in a little more depth. So if you can look at your screen, what you can see is this big, beautiful box that's in green, which Alonzo Coleman from my team drew for us. And that's the region. You can think of it as a continent or a part of a continent, but a big, giant geographic area. And you can think of the availability zones as a data center, because that's really all they are. Availability zones are just data centers. So big, giant geographic region, data centers in between these regions. Now, if you didn't know, what is a data center? It's a giant building that's got an enormous amount of power coming into it, that's got multiple sets of generators, multiple sets of transformers, and backup batteries should the power go down. It's got racks, and these racks are filled with routers and switches, which get your traffic through the network. It's filled with servers, which do the computing. It's filled with storage area networks, such as block storage, object storage, and file storage systems. It's filled with load balancers, physical load balancers, firewalls, and all kinds of cool stuff that I've spent my life architecting. Because what is cloud computing? It's just buying space in somebody else's data center. So region, giant geographic area, availability zone, a data center inside of a region. So let's talk a little bit about local zones. If I am working in a campus and the campus has a data center there, guess what? It's basically instant for me to reach my systems. Fast, low latency, high performance. And I'm going to tell you right now, the cloud cannot compete with the data center in terms of performance. And we'll talk throughout this why. A lot of it has to do with storage, but right now we're going to talk about latency. If we have a fiber optic cable that goes to the cloud provider, there may be 1 to 3 milliseconds of latency or more by the time it goes through all the routers, switches, and fiber optic connections to the cloud. Some business applications need much less than the 4 milliseconds of latency, 3 or 4 milliseconds that we may get on the cloud, or even 2. They may need, in certain applications, for example, in the financial space, a nanosecond can literally mean millions of dollars per year. So highest performance is always going to be in the data center, but AWS and all the cloud providers know this, and they're giving you an alternative, and that's called a local zone. And basically, as I mentioned, we've got the large geographic area, which is a region. We've got an availability zone, which is data center, but that data center may be 1,000 miles from you, or 1,600 kilometers, for example, equivalent distance. It's long distance. It's a lot of latency to reach that cloud. So what if you could put a data center in between you, the customer, and the cloud? And I'll draw that out for you in a minute. That's what a local zone is. It's an extension of the region, which is basically a data center that's closer to you than the actual data center or the availability zone in the cloud. And by doing so, it enables you to put the compute power closer to you, reducing the latency dramatically. So the way this is going to happen is you basically have to opt into a local zone. Then you'll create your subnet in the local zone, and inside of that subnet, you're going to basically your virtual machines, otherwise known as your EC2 instances, your load balancers, your containers and container orchestration, whether it be ECS or EKS. It should be EKS or bare Kubernetes, and we'll tell you why later. And in certain local zones, you can offer even more resources than you actually would be. So let's show you what it actually looks like, and then I want to whiteboard it out for you with you live to give you a really, really good feeling about how this works. As you can see, we've got this large geographic region with this nice light blue color, and we've got these data centers inside there, and then you see a local zone. But I don't really love the way they described it, which is what it is. So let's really whiteboard it out. I love using whiteboard capabilities to really demonstrate things. So let's say here is your campus. What's going on with me? Oh, bear with me a minute. So here's your campus. This is where your users are, where everybody works, the ones that are not working from home. And while we're at it, let's pop in the cloud provider and say this is a AWS cloud. It could be any cloud you want. Helpful if I spell it correctly. And this is an availability zone. As you can tell, there's a pretty big distance between them. So what is a local zone? One more time. It's basically what's going to happen is we're going to put a data center in between us and the cloud. So what happens is we connect from the campus to the local zone, and then we can also, the local zones are obviously connected back to the AWS cloud. And by being closer, you can see this distance is smaller than this entire distance, the entire length of the cloud. So look how short it is to go from the campus to the local zone versus this line that I'm drawing here represents the longer distance to the local zone. So local zones improve performance and reduce latency by getting it closer to you. Now let's talk about edge locations, and we're going to cover this much more when we start talking about CloudFront. And we will spend a lot of time on CloudFront later in the week. An edge location is basically a point of presence, which we'll talk about in a minute, which is closer to you, the users. And CloudFront is used as a content delivery network. And I'll show you how that works. But basically speaking, if I wanted to go to a website, I can go to the website, and the website can serve me. But what if the website's far away? I'll have to go to this website in Greece. It's pretty far away. But if they had a content delivery network, I could go to the Greek website. And then my wife could go to the same Greek website. And since she's living from the same house, I go to Greece and I'll show you how that works with my data. And she only has to access it locally in, say, Miami. And that's a beautiful way to reduce load on servers, which we'll talk about in much more depth when we talk about content delivery networks. And after that, we'll spend a tremendous amount of time talking how to tune them and performance to them and why you need more than one content delivery network, but we'll show you that as well. So edge locations are a local place for the user to access your data. So, and basically what's going to happen is it's going to get your traffic off of the internet and onto the backbone. Why? Why do we want to get our traffic off of the internet? Internet performance is best effort. It's not guaranteed. But on a private network, we can improve performance. Plus, edge locations cache local content. What does that mean? I'm going to walk you through an example right now. So in this example, here's where we're at. We've got basically a website that's got some static content and some dynamic content. Static content sitting there on our object storage, which AWS calls S3. Our dynamic content sitting on virtual machines, which AWS branded EC2 instances. All cloud providers have them. Same virtual machine we've been using in the data center for 20 years, invented by VMware, with a slightly different hypervisor. And then what you can see is these edge locations, and then you can see the user. So here's the way it's actually going to work. This user over here wants to access www.gocloudcareers.com. So the user reaches out to the edge location. The edge location does not have it. So the edge location forwards it to the regional cache, which then sends it to the source, which is these virtual machines over here. Now at this point, they respond, the regional cache receives them information. This information is sent to the edge location, and then the user gets access to their information, and everybody's happy, right? Beautiful. Now, that's the first time. Now, the second time, me as a user or somebody else as a user goes to that same page, it hits the edge location. The edge location says, I have that information, and they send it back to the user. So what did you notice? In the first response, and this is huge when it comes to scalability, high availability, and preventing DDoS attacks, and we'll talk much more about that when the time is appropriate throughout the course. The first one, the message went all the way to the servers. So this means the servers had to do some work. And we had all this latency, and then the response back went back to the user. But on subsequent attempts for the same data, what you can see is what happens here, which is what makes this so exciting, is the user hits the local cache or the edge location, and their data, oops, didn't mean to do that, their data is sent directly back to them. And their data is sent back to them. So now I want you to imagine this. Imagine if, say, Katy Perry or Taylor Swift were to show a new photo of their cat on the internet, and everybody wants to go to that website. Imagine the servers we would need, and how many thousands of servers if Katy Perry's or Taylor Swift or any big famous actor, actress, or musician posted something, and then the whole internet went to them. It'd be crazy. But here we could actually have a single server, or multiple servers, but not thousands of them, and the content delivery network will take care of all the caching and replication, and basically it saves the load on our servers. So content delivery networks are huge, and edge locations take care of content delivery networks. So let's talk about what we talked about. We talked about the AWS Cloud and how it is organized. It is organized into regions, which are huge geographic areas. It's organized inside of those geographic areas. There's multiple availability zones, otherwise known as data centers. And I told you what a data center is. Then for low latency based computing, we've got something called the local zone, which is a data center closer to us than the actual cloud. And then we talked about edge locations, which is where the AWS CloudFront is. It's a point of presence, which basically holds the content delivery network. So now you know how the basic cloud is organized. I think this is the time that we should answer some questions. So let me answer some questions before we go into the next topic.
All right, and this is Chris, the man behind the scenes. So just to remind everybody, we will be taking questions related to the content that has been covered. If there's questions about things that we have not covered yet, we will not be taking those. We'll take those when we cover that content. If there are questions related to the cloud computing careers or cloud architect career or cloud engineer career or anything not related to the AWS training content, we will not be taking those questions either. So only questions related to the content. So let's get going.
What is the difference between a local zone and an edge location? A local zone is a data center between you and the cloud provider where you put your servers for reduced latency. An edge location is part of a content delivery network. And when it comes to the content delivery network, it's a place where they basically have a private network between your web servers and your users. So local zone, put a data center between you and your customers. Edge location is another data center, actually, where you actually connect to view publicly available website content. So one is for website content and one is for a compute power. Mode. Here's what if CloudFront for any region goes down? Mode. You should never use a single cloud if it matters. Even AWS uses multiple content delivery networks. They use Fastly, they use CloudFront, they also use Akamai, and they're just the three that I receive in my geography. You can't use a single content delivery network if it matters, and you sure can't use a single cloud. And even in a single cloud, if you use all the regions in the world, here's what happens. If the cloud has a network problem, it can take down the entire cloud. If the cloud has a control plane problem, which is what orchestrates the cloud and makes it work, the whole cloud gets down. If the cloud gets hacked, And lots of clouds have been hacked recently. They can take the entire cloud down. So you should never have a single content delivery network. If it matters, meaning high performance, high availability system, then you should never use a single cloud. Great question, Mark. Igor, is a point of presence also a data center? It is a data center, but a point of presence is different. A point of presence is basically a data center where all your big internet service providers come together. So you might have Verizon in there, AT&T in there, Telefonica in Spain, NTT in Japan, Etisalat from UAE, for example, Orange, Vodafone, and they're all in the same building. And that way, the internet service providers can connect to each other in a high-speed environment. So yes, it is also a data center of special time. Francois, what determines the edge location? I don't exactly understand what you're asking. Val, who is building the local zone? AWS built it. They own the local zones. All cloud computing is renting space in somebody else's data center. Are local zones in a fixed location? Yeah, they have to be. They're a data center. And they're going to be wherever AWS decides to put them. Difference between edge locations and CloudFront? CloudFront is just a content delivery network. Edge locations are the buildings that hold the content delivery network. Does edge location being a delivery content have storage? Yeah, of course it's going to have storage. Remember, lots of DRAM and lots of storage. How do you decide about the number of you don't decide the number of edge locations. AWS has a certain number. Last time I checked, it was like 227, but it changes all the time. And you get to use all of them, or as many of them as you want to use. Yeah, is it mandatory to have a content delivery network? Not at all. There's lots and lots and lots of websites that don't have content delivery networks. Of course, if you get hit with a DDoS attack, it's pretty much over unless you have a content delivery network. And you'll need 10 times as many servers, and you'll have to spend far more money without a content delivery network, but it's not mandatory to have them. Can I differentiate between a data center and edge location? Well, they're both data centers. A data center that you own or your VPC on the cloud, your virtual data center, is where you put all your compute, your storage, your security appliances, etc. That's your virtual data center. And a data center is a building with all your servers and storage that's designed to do compute. An edge location is a data center specifically built for the content delivery network that is owned by AWS. Where is the main data center for cloud? There is no main data center. There's large geographic regions, and inside of them, there's multiple data centers. Which ones do you need? If you're in Florida, you're going to use something on the east coast of the US. If you're in Mumbai or Bombay, you're going to use something that's in India. If you're in South Africa, you're going to use one that's in South Africa. So it's based upon picking something that's closest to you to minimize the latency, which is still going to be there. Chester still don't understand how local zones and edge locations differ. Are they're both used to lower latency? Yes, they're both used to lower latency. A content delivery network is only used for websites. And a local zone is a data center where you put everything. Businesses don't just have websites. They have human resource systems, financial systems, maybe banking, trading systems, unified communication systems, critical business applications, supply chain applications. That's what you put in a data center. All an edge location is a place to put your content delivery network, and that is it. Can a local zone and an edge location coexist in the data center? If AWS wanted to build them that way, of course they could. They could separate any way they want, but why would they? You're going to put your AWS state local zones in the place that's going to have its compute power, and you're going to put the edge locations, it's going to be someplace else in most cases, because you want to maximize the space, and you're going to be using different technology. I also see there's lots of questions in the chat box related to things that are coming later. We will answer them when we actually cover the content. Are content delivery networks using load balancers like F5? Probably. I mean, they don't tell you exactly which ones they use, but generally speaking, if it matters, you're using an F5 load balancer, and I'm sure their data centers are. Edge locations can be used for both static content and dynamic content. And an edge location stores data temporarily. Exactly. How the company data centers connect to AWS data centers? We're going to talk about that soon with a wide area network, and we'll talk about two of the more common ones that are part of the certification, and we'll mention two of the other more modern ways that we can also use, which are not part of any of these certifications. And as location, some kind of proxy? No, it's not a proxy. A proxy server is something very different. Can you safely say an edge location is a DMZ of AWS? Not even close. A demilitarized zone, which we'll talk about when we talk about security, is related to how you set up your things. An edge location is a content delivery network. It's like a cat and a shark. They're completely unrelated. A VPN just means you're creating a private connection inside of a public network. That's it. Site to site is one person to one person. And a multi-point VPN connects multiple people. Same thing. You do not have to use a local zone. Most people don't use local zones at all. Local zones are used when you want to have low importance things. So, Adele, as when it comes to architecture or performance engineering, what are the business requirements? Can the business tolerate the latency of going to the cloud? If it's a financial thing with an algorithmic training system, it can't. Can it tolerate the local zone? Maybe, but maybe it needs to be in their private data center. So it's all based on the business requirement. There is no set in stone thing for anything. You would go to the, you can go to that.
And so now I'm going to let her put a new link in the chat box because it looks like our bit.ly link is being blocked by some of the users' setups. So there, I'm posting a direct link to our exam guide for everybody that has been indicating that they're having difficulty.
Good. I want to make sure everybody can get access to as many free materials as possible.
There we go. All right, there we go. All right, now back to you, Mike.
Okay, so we're going to briefly discuss some of the available kinds of cloud architectures that you can use very briefly, but we can only cover it a little bit. A lot of the how to design hybrid cloud, multi-cloud, that's what we do in our cloud architecture development program, but this is a certification training, which is very different than training to get hired. So I want to keep it focused on, what's covered in a certification. We're going to be talking about hybrid clouds. We'll talk about single clouds, and we'll also talk about multi-clouds. So what is a hybrid cloud? A hybrid cloud is very simply, you've got your data center and you connect to the cloud. And you use both at the same time. Hybrid clouds are actually your best option. Why? You have the best performance in your local data center because you don't have to wait. So for example, later when we talk about storage, and AWS says we have fast storage, and they talk about their 250,000 IOPS, which we'll talk about later. And the data center, I can get 19 million versus 250,000. So, I mean, it's not even close, the kind of performance we can have in the local data center versus the cloud, plus we've got the latency. So if it really matters, you keep it in your data center. Now, things that run 24 hours a day at full capacity, 7 days a week, are far, far, far cheaper to run in your data center than they are in the public cloud. But sporadic applications and scaling applications like a website, which might be slow all year, and then high on, say, Christmas, Hanukkah, or some other holiday, do better on the cloud because it's cheaper to basically buy what you need and scale out as necessary versus in the data center we purchase for peak. So hybrid cloud, maybe I'll whiteboard it out for you so you can kind of look at it. And with the hybrid cloud environment, what do we get? the highest performance, and in most cases, the lowest cost. But the hybrid cloud means you have to have some smart people that truly understand networking and data center technologies, which means it's a bigger staff. So here we've got our data center. And what exists in our data center? The same stuff that exists in the cloud. Racks filled with servers, multiple power companies, air conditioning units, backup power, routers, switches, firewalls, physical load balancers, servers, storage, same stuff you get in the cloud. So a hybrid cloud is we've got our data center. And then we've got, let's not even do that. And then we've got a cloud provider, but in this case, we're talking about AWS. And in this environment, to kind of, let's cover this. Fill, no fill, see if that'll do it. And that's in our AWS data center. And what we might do is we typically have two availability zones, A, Z, and we'll have another availability zone, which is a data center. And this we're talking about as a truly high availability system. Why? We've got the AWS Cloud and our own data center. And that way, we will use two connections, and we'll talk about that later when we cover some of the basic networking things. This is a hybrid cloud. So highest performance, highest reliability. Why? AWS goes down, both availability zones, they have another power failure or whatever it really was. Guess what? Data center's still up. So I want you to think about use cases where a hybrid cloud is beautiful. What about a hospital that's got electronic health records? If and when the AWS cloud goes down, and I promise you it's going to go down, and it's gone down plenty of times, as has to the Azure cloud, the Google cloud, because all tech fails. And you got people that are undergoing surgery, having medical emergencies, and AWS cloud goes down. Guess what happens? If all your stuff is in AWS, people are going to die. Now, that's not a good solution. So in a hybrid cloud, you got your data center, which has got some of your stuff. You got your cloud, which has got the rest of your stuff. The cloud goes down, it doesn't matter. Your data center goes down, it doesn't matter. This is true high availability, high performance system. So that's why we use a hybrid cloud. Hybrid cloud, disadvantages. You got to have a lot more smart people in your organization. You need good networking people, good data center people, and it's a lot more management. But overall, typically speaking, long-term, it's cheaper. Now, let's talk about a pure cloud, say a single cloud deployment. What's that good for? I'm a new business, for example, and I don't know what my capacity is. I don't have a lot of money to buy stuff. I go straight to the cloud. And by going to the cloud, I don't have to purchase additional capacity. I can grow and scale as I need, and I don't have to come up with the money or the financing to buy the tech. As that business grows, it better go to multi-cloud if availability is important, or a hybrid cloud. But a single cloud, a pure cloud is great because there's nothing to buy. So if it's a startup, if it's somebody that's looking to build stuff fast, it's much faster to build it in the cloud than it is to buy hardware. I can set up a virtual machine in the cloud in 6 seconds or less. It's nothing to do it. I taught a 6-year-old how to do it. And she was real cute doing it too. And in the data center, I got to call Dell. I got to negotiate a contract. It could be 6 weeks. So 6 weeks versus 6 seconds. That's why we love the cloud, because it's so agile. On the cloud, people are already connected to it. So we'll show you later how you can use the cloud for transit. Let's say I'm a sneaker manufacturing company and I need rubber. And the rubber companies are connected to the cloud, and I'm on the cloud. I can just reach out to them directly through the cloud. So it's great for that. So kind of keep that in the back of your mind. What's that look like traditionally speaking? It looks something like this. You've got your organization, and you either have a private line, otherwise known as an AWS direct connection, or you've got a VPN, a virtual private network, and we'll talk about more of that when we talk about connecting to the cloud. We'll get into that stuff in some depth. We'll cover it in the depth of the Certified Solution Architect Professional, and then some, because you need to know that to be functional. We're more concerned about you having knowledge than passing an AWS certification exam. Even though this is a free AWS course, I want you to know a lot more than you would otherwise. So you can see organization's got a router. The router connect on a private line connects to the cloud, and you've got your basic cloud environment. Now, that's generally speaking good, but, and here's the but, If that cloud goes down, you've got nothing. And having nothing is not a good solution. I told you what exactly can happen, say, in an environment where it's healthcare, cloud goes down and people die. It's terrible. But what about a bank? You know, there's a lot of banks where seconds of downtime can literally mean millions of dollars lost. They can't tolerate a cloud provider that's down for 4 or 5 hours. So what did they need to do instead? They need a multi-cloud setup. What's a multi-cloud setup? Is truly the best, and anybody that really matters. And 98% of organizations are now multi-cloud. 98%, which means if you don't know the underlying tech, and that's where we're going to spend so much time focused on the underlying tech, and you only know one cloud, basically there's only one company that can hire you, and that's AWS, because 98% of businesses know multi-cloud. So we're going to show you multi-cloud here, just so you're aware. And when we cover the technology, we'll cover it so you'll know what it is, if it's AWS, Azure, or Google, because it's all the same thing. Like the Who song, meet the new boss, same as the old boss. A cloud is just a network and a data center that's been virtualized. So let's go build a multi-cloud environment, just to give you at least show you what it looks like. In a multi-cloud environment, we've got our campus. And on our campus, we could have a data center, or we could just have a campus. We will then have 2 clouds, and probably 2 availability zones per cloud. Let's say this is AWS. Let's say this is Azure. And there's lots of cloud providers other than these 3. We've got routers connecting to each one. So let's pop a router here, a router here. Now, when you connect to the cloud providers, they're using virtual routers, but we have real routers, and we'll talk more about what the implications are of that later. So here we go. We're connecting to AWS. We're connecting to Azure. Now, I want you to understand how great this is. In this environment, AWS goes down. Like that global outage they had a couple of years ago. They were down for half of the day. Now it's a hospital. They're on 2 clouds. AWS goes down or Azure goes down. Who cares? Nobody's dying. It's the bank. They're not losing millions of dollars a second because the systems are up. 98%. 98% of organizations use multi-cloud. And that's why we're talking about it in our AWS full course tutorial, because I want you to know more than what's covered in the certification, because I want you to have a future in tech. So the next topic is going to be connecting to the cloud. Now, we're going to get relatively into some deep weeds with this. Chris, how long has it been since our last question and answer session?
About maybe 10 minutes-ish.
Well, let's spend 5 minutes going over some questions here, and then I want to get into the how to connect to the cloud, because that's where it gets fun. But I just want to make sure, because that's going to take 20, 30 minutes to cover that.
All right. So let's see if we've got any questions. Looks like we might also have a little bit of delay for some people because of seeing some questions related to the previous section. So I think they're on a delay. Here we go.
Eugene, in a multi-cloud setup, you do not need to have your own data center because you've got the redundancy of a cloud. And truth be told, with infrastructure as code, it's nothing to set up multi-cloud compared to a single cloud. It's all the same tech. It's all the same thing. So multi-cloud, you do not need to have your own data center. But many organizations are doing hybrid multi-cloud. And why are they doing it? In their data center, they're running the high-performance things and the things that use a lot of capacity because it's cheaper in their data center than the cloud. How much cheaper is it, Eugene? Well, I'll give you an example. Let's say you needed a server with 128 cores and 4 terabytes of DRAM. In your data center, you can buy that server from Dell, for example, for about $140,000, which sounds like a lot, right? And you can keep and run that server easily for 4 years. Now, in the AWS cloud, on-demand pricing, it's $16,000 a month. So in 10 months, you're paying more on the AWS cloud than on the Azure cloud. Over the course of 3 years, you're saving well over $500,000 not having that server in the cloud. So kind of keep that in the back of your mind. But for sporadic stuff like websites, The cloud's much cheaper because you purchase only what you need. So that's up to the business. Just to clarify, if you're using a single cloud, that means you're only using one cloud provider like AWS or Azure. Exactly, Chalice. In a multi-cloud, if we choose specific services, would we have to achieve the same level of continuity if one platform is absent? Well, let's make this very clear. If you don't use the bad services, and we're going to cover those bad services, the DynamoDBs of the world, the Amazon Auroras of the world, the Elastic Compute Services, any proprietary stuff, and that's why they're bad. It's not that they're bad technology, it's that they're proprietary. If you use an industrial grade database like an Oracle one, or you use like a MySQL, for example, or a MariaDB, you can put that in 3 clouds and you never have a synchronization problem. It's only when you use proprietary services, and that's why the cloud providers love you to use proprietary stuff, because it's like you're handicapped and you can't leave without spending millions of dollars. There was a song by the Eagles, it's called Hotel California. You can check in anytime you want, but you can never leave. That's what happens when you use proprietary services, and that's why we don't recommend them. Let's go to the next one. How multi-cloud architecture works? Same way that businesses have in the last 20 years when they had 2 different data centers and they connected them with networking. Simple, it's nothing. I've been dealing with multi-clouds forever. Can organizations claim 98% uptime if they have multi-planar but only carry over like Verizon? Well, Michael, getting to 98% uptime is nothing. So what we're really talking about is, you can get 3 nines availability or 99.9% of the time, which is 8 hours of downtime per year. That's nothing to do. You can get close to 4 nines availability on a single cloud, which basically means an hour of downtime per year. But to get to true high availability, which is 5 nines, and there's not that many of us in the world that know how to do it. I've been building 5 nines network for decades now. We've got less than 5 minutes of downtime per year. Now you need multi-cloud to really do it intelligently, and lots of businesses need that. In a pure single cloud, isn't the service already high availability? No. A network failure, a control plane failure, or a hacking event causes the system to go down. Let's talk about AWS's power failure. Now, data centers don't have power failures, but they had a power failure and took down the global systems for about 6-7 hours. And then they had another power failure, and then they had another misconfiguration, they had another something. If you believe those answers, and let's just give them the benefit of the doubt, no, they're not high availability. Any disadvantages of multi-cloud? No. 1 is none and 2 is 1. It's like having 2 flashlights with you in the woods. What handles the request redirection of multi-cloud if one goes down? It depends how you set it up. Usually DNS, but it could also be BGP. What do I mean proprietary services? Good question. Anything that is AWS branded or Azure branded or Google branded. So if you want to do container orchestration, you can use Kubernetes. Everybody uses it. Red Hat has their OpenShift. VMware has theirs. You can build your own Kubernetes cluster in all clouds. AWS has this proprietary Elastic Container Service. Use that, you're stuck. Use DynamoDB, which is an AWS database that only works on AWS. You're done. You use Amazon Aurora, you're done. Use AWS WAF, you're done. But if you use normal systems that you can stick on all clouds, it's never, ever, 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 ever a problem. So let me refill my water cup and let's get back to the content. And I want to make sure that you guys all join us on Thursday. We have it almost every Thursday, but this one's going to be at a special time in the evening for all of you. And we're going to tell you everything you need to know to get your first cloud architect job here. And believe me, certification versus getting hired and building an incredible career are very different. We'll tell you everything you need to know, the skills you need, the skills you don't need, how to get hired with experience, how to get hired without experience, all that you need to know, because I want you all getting hired. Anybody can pass a certification. But going from certified to hired, that's our world, and we're going to tell you exactly what you need to know. Because I see there's career questions, and I love answering career questions. And Chris, while we're at it, if you can have somebody from the team post the guide to how to get your first tech job, which we have, as well as the one on how to change careers, and also please post in the chat box the how to get your first cloud architect job. And okay, let's go back to the content, because we can't post all these things, but at some point we'll have some. Okay, so let's talk about connecting to the cloud. My favorite thing to do. Why? Because I'm a networking guy. In fact, I've been in networking so long that back in 1999, my manager said, Mike, I want you to become a CCIE. So 6 months later, I was, and now my number is 7417, back when it was a miserable 2-day exam. It's been made simpler since then, but you know, I love networking, and I spent a decade at Cisco as lead architect for the most part, taught lots of their engineers and architects at Cisco as well. So connecting to the cloud, if you're going to use the cloud and you've got private information, guess what? You got to connect to it. You got to reach it some way. And there's really 4 options for connections. There's 2 that are covered in your exam. I'll briefly cover the other 2, just so you know. But for your options to connect into the cloud, the first thing we're going to talk about, and these are the 2 that are on the exams, are virtual private networks. And then after virtual private networks, we'll talk about direct connections. And after that, I will basically give you a brief overview of software-defined networking and a brief overview of SASE, which are the 2 modern systems that we use. If it doesn't matter, and what do I say if it doesn't matter? So when you go to the internet performance is never guaranteed. Never, never, never. Internet traffic is best effort, which is why you can get a 10 gig connection to the internet for $900 a month. But if you get a private line where you own the performance, it might be $25,000 a month or $50,000 or $100,000 a month. You know, that's the reason why, because one is guaranteed and one is the public internet. One is completely private and the other is not. So a VPN or virtual private network is a means to create a private network over a public network. Back when I worked on my first cloud, which was Frame Relay, we had a public cloud, and we built a virtual private connection over that cloud. That was a VPN. Then around 1998, we used another cloud. It was called the ATM cloud, and we built a virtual private connection over the public cloud. Then we had this BGP cloud, where basically we tunneled our traffic in something called the VRF through a cloud, MPLS cloud. And then after that, we created another one called the VPLS cloud. I've been working on clouds now for 25 years. In this case, what we're going to be dealing with is when we talk about VPNs, for the most part, are basically creating a private connection over a public network like the internet. So how does that work? The internet is public. And if we deal with public connections, we have no security. Guess what else we can't use over a public internet? Private IP addresses. You know those RFC 1918 addresses, 192.168/16, 10.0.0.0/8, and the 172.16.0.0/12. But with the VPN, we can tunnel those private addresses in a secure manner over the public internet. So I'm going to give you a visual of what it is, then I'm going to talk about it, and then we're going to work through an example of a VPN connection. So let me show you what it looks like here. We've got our data center building, and this could be your house to somebody else's house. This could be a corporate data center to a corporate data center. And this will also be your data center to the cloud. Same thing, doesn't make a bit of difference. Which you can see is a router on both sides. AWS calls it a virtual gateway because it's a virtual router, not a physical router. In your data center, you buy a physical router. You connect both to the internet. And guess what? Everybody anywhere in the world has the internet, which is what makes this so good. Then you create what's called an IPsec tunnel, which we'll talk a little bit about. And then I'm basically going to build you an IPsec tunnel. We can demonstrate it with, my favorite thing to use to demonstrate, which you guys that know me know what it is. And if you guys that don't, you'll get to watch me do it in a minute. It'll be lots of fun. So I told you the internet is not secure. So what IPsec does is it encrypts your traffic from point A to point B. Encrypts it. So nobody can see it unless they have the decryption key. All they see is gibberish. And because we're basically creating a tunnel and we're shoving our traffic and data through the tunnel, not only is it encrypted, but we can pass any data we want. Now, IPsec is typically used to create 99% of VPNs in today's world. So let's talk about what that actually does. First thing is we have to authenticate the peer. Actually, let's just draw this out. I want to make sure that you truly, truly get it. We're going to be authenticating the peer. So in this environment, what we're going to do is as follows. A couple of months ago, my beautiful cat Cindy, the pretty little girl sitting on the left side of the screen, brought in the house this rabbit, who's the white rabbit drinking out of some water that I put in my garage, along with some spinach that I put out for the rabbit. I got to rescue the rabbit from my cat, fed the rabbit, and then restored the rabbit back to being very healthy. But let's say Cindy, the cat over here, who's on the left side, wonderful girl, by the way, is best friends with, let's call it Peter the rabbit over here. And they want to talk to each other. Now, let's say Cindy on the left and Peter on the right have some really critical things to talk about, and they don't want anything to anybody else to know. Maybe the cat and the rabbit are building an alliance against dogs because neither one of them likes dogs. I don't know. It doesn't matter. So what they want to do is they want to connect to each other, and they're going to connect over the internet. But if they connect over the internet, here's what's going to happen. Other people will be able to see their traffic. And now it's not going to make an alliance between a cat and a rabbit look good to anybody. So we're going to connect them through a VPN. Now, the first thing that's going to happen is they both have to connect to the internet. Now, how do you connect to the internet? You get a router. The router connects to the internet. So basically, we've got Cindy connecting to the internet, and we've got Peter the rabbit connecting to the internet. And then we're going to create this encrypted tunnel, which is what it's going to look like, is it's going to look like that going through the internet. Everything inside this IPsec tunnel is encrypted, meaning no one else can use it. But is that good enough? No, because here's the other great things that IPsec does. IPsec first authenticates the peer, because what if Cindy thought she was talking to Peter the rabbit, but she was really talking to Wally the wolf, pretending to be Peter the rabbit, and Wally the wolf wants to eat both of them? Well, that'd be a disaster, right? So first part of IPsec is authentication of the peers. They have to make sure that in between them, everything is authenticated. Now, next, Cindy and Peter need to make sure that their messages have integrity. What does this mean? I'll take you out of this for a minute. What if a doctor prescribes a medication and somebody adds a couple of zeros to it? Somebody's going to die. So we need to know the messages is not going to change. Same thing as if you wrote a check for $1,000 to someone and somebody put a couple of zeros and turned it into $100,000, you'd be in trouble, right? So IPsec provides authentication. Cindy knows it's Peter, her buddy. Now, Cindy also knows that if she sends Peter a message that says, when are you coming over for coffee? And the rabbit says, I don't like coffee, but I like spinach, that those messages haven't been changed. The last thing IPsec provides is something called non-repudiation. What is non-repudiation? Non-repudiation means that after Cindy says, I've got the world's greatest spinach and carrots for you, Mr. Rabbit, and Mr. Rabbit says, I'm coming over, Cindy can't say, when the rabbit comes over for dinner, that she never sent the message. So, authentication of the peers. Message integrity, meaning whatever the message has not been changed in transit. And of course, non-repudiation, which means the person can't say after the fact that they did not send the message. So what's so great about VPNs? Well, everybody has internet access and it is real cheap to use. Now, how about speed? I want to set up a VPN connection. I do it all the time. I create an IPsec tunnel between me and a peer. I can do it in about 30 seconds. I go configure my router, his router, and it is done. It's that simple. I can create a point-to-point connection between me and Chris. I can create a multi-point connection between me, Chris, and Alonzo, and we can all talk to each other over these connections. Fast, cheap, love it. But it's not all sunshine and roses when it comes to VPNs, because VPNs use the public internet, and the internet is slow compared to a private line. So internet performance is not consistent. There's lots of latency. We don't know how much bandwidth we're going to get. And it could take 20 router hops to get to the destination on the internet versus 2 router hops, 1 month, to get to the destination over a private line. On a private line, our traffic's guaranteed to get to the destination. On a VPN, there's no guarantee. So kind of keep that in the back of your mind. Let's talk a little bit about AWS VPNs, because this is an AWS certification exam. AWS VPNs are typically set up between a data center and the VPC, which is your virtual private data center. They call it virtual private cloud. We'll talk much more about that later. And that's a site-to-site VPN. But what if you wanted to connect to multiple places? That's a multi-site VPN. So keep that in the back of your mind. The packets come into the router. The routers get encapsulated into an IPsec message, and it's tunneled throughout the internet. Now, when these tunnels come up, the routers or firewalls doing the encryption basically do a key exchange, which talks about the security algorithms type and the encryption type that's going to be used along the way. And if you want, you can set up dynamic routing over BGP. I can't imagine why you wouldn't if you've got multiple connections use BGP, but keep that in the back of your mind. Otherwise, you can configure a static route. Static route means you manually tell the routers how to reach the destination. Dynamic routing means you basically keep them. So now you know about AWS, about VPNs. Now, this is where it gets a little ugly. AWS will tell you that their VPN is highly available because it's a virtual router. They'll tell you only need to set up one. Because what happens is, let me show you in this graphic, and I'm going to show you the weak point of their strategy. What they're showing you is when you connect over your VPN to basically the gateway connecting to, it automatically creates a connection to 2 different availability zones. That's great, right? It is. Their router won't go down. That's great. But there's a major flaw in this system. The flaw in the system, if you were to believe that this is acceptable, is this following. This is your router over here. If your router goes down, I don't know what happened there, but if your router goes down, guess what? You lose both connections. So even though the AWS end is high availability, what you can't see is your systems can go down. So what do you really need to do if you want high availability? Well, you need to create a situation that looks like this, where basically you've got your data center with 2 routers and you connect to 2 different locations in AWS, and you've got 2 different internet connections. One internet connection goes down on router 1, who cares? Router 1's internet connection goes down, who cares? Because router 2, this is how you have high availability. No single points of failure. When it comes to high availability, 1 is none, 2 is 1, and 3 is greater than 2. So how do you set up a VPN? Well, it's pretty simple. You determine the virtual gateway you want to connect to. You pick a routing method, static routing or dynamic routing. If you know anything about routing, you're a routing and switching guy, you're going to use BGP. If you don't, you may use a static route. You'll pick your tunnel configurations, and you'll be done with it. Now, there's the options you're going to have that you need to know for the exam. You can basically use the default VPN environment, or you can set up a custom environment, which gives you the flexibility to set up your better routing. Great for network engineers who now work in cloud computing, which is a lot of them. The virtual gateway, which is what you connect to on the AWS side, will be automatically configured based upon the parameters. And if you don't know how to configure a router, and I strongly suggest that somebody on your team knows, the AWS Management Console will spit out the command line interface that you can paste into your Cisco router. For example, it'll say config t gigabit Ethernet 0/0 IP address, and it'll give you the address. It'll type a no shot command, and then it'll talk about the interface tunnel 0 configuration. It'll give it to you. We're getting to a world where ChatGPT and all these and the service providers can basically give you the configuration or the hands-on doing, but what it can't ever give you is the how stuff works, which is why we're focusing so deeply on this. And it'll give you an auto configuration for Cisco routers, Juniper routers, Palo Alto networks, Fortinet, all the main stuff. And you can monitor the performance of your systems with CloudWatch. Now that's a VPN. But if it matters, you're going to use a private line. Now, what is a private line? It's a wire, effectively, between you two locations. Now, with AWS and Azure, they make it a little more interesting, and I'll show you. But basically, it's like a wire. It's a virtual wire. So why would you use a direct connection? Well, guaranteed bandwidth, consistent latency, and highest reliability. Now, you may not be able to get enough speed on a single direct connection. But if you have a 10 gig direct connection and you need 40 gigs, well, you can bundle up to 4 10 gig direct connections into what's called a link aggregation group. For those of you that are from the networking world, port channel, ether channel, it's the same concept. We can bundle 4 links and they look like a single link. Because if you don't do that, you got some fairly complicated routing to deal with, which, again, we love because we love routing. Now, when you connect to the cloud, you're basically dealing with a 1 gigabit connection or a 10 gigabit connection. Now, virtually, I'll show you what it looks like, and then we'll get into the reality of what's really going on here. Virtually, it looks like this. You've got your organization, which has got a router. You connect to the AWS Direct Connect environment, which connects you to your systems. That's what it looks like logically. It's not exactly what's going on, and I'm going to walk you through it, but let's talk about the underlying technology. And you may see some questions in the AWS Certified Solution Architect Associate or Professional. This course is kind of a hybrid between the two because I want you to know more. It's going to be a fiber optic connection. So the router itself is going to need something called the fiber optic port, and then you're going to need to stick an optic in the port, which is basically your lasers. Now, the basic specs, which could be a test question that you're going to see, is for 1 gig, you're going to use single mode fiber, 1000 base-LX. 1000 base-LX. Now, if it's 10 gig connection, you're going to use pretty much the industry standard of 10G base-LR. Now, we're getting a little complicated here, but if any of you ever worked in networking, you know fiber optics, there's basically two lasers. A send laser and a receive laser. And what can happen is you can have one system go down, one laser go down, and the system stays up, in which case all your traffic gets lost anyway. So the good news is AWS, like the main router providers and switch providers, also supports bilateral forwarding detection, which basically means if the send laser goes or the receive laser goes, it tears down the connection. Now, when you're dealing with AWS, it's not exactly a wire. It's more of a pseudo wire. And because of that, we're going to have to use an 802.1q tag. And we're basically going to create a trunk port, which we use to connect to AWS. I can't cover trunking because that would be a 4-hour conversation. That's the kind of deep depth we provide technically in our Cloud Architecture Development Program. It's just way beyond the AWS Advanced Networking and other courses as well. It would to really cover trunking, we'd have to get into some pretty deep depth. But there's a CCNA Bootcamp on our channel, and you can watch that to learn a lot more about trunking and VLAN tagging. And some of my team can pop the link of that free course for you. So let's really look at what a direct connection really feels like. So what really happens is you've got your on-premises environment where you've got a router. The router is going to connect you to what you can see over here is to the direct connection location. Now, if you notice, you've got your devices or customer edge devices, which are in gray, and you've got these orange direct connection routers. So what has to happen is as follows. You connect to the direct connection location, and then the company has to run a cable, just a simple wire, between your router or switch and their router or switch. And then your traffic gets backhauled all the way back through the AWS backbone to your account. So notice, I want to say this one more time. You buy a connection to this direct connection location. And if you need true high availability, you're probably going to need 2 of these, like we demonstrated here. You're going to connect to the direct connection location. And if you see on the bottom of the top link, whoops, I didn't mean to do that. But if you see that orange little cable connection, that is connecting your router to the customer edge router. And there you go, how it works. Now, in order for all this stuff to happen, basically a few things are going on. When you buy this direct connection, you're essentially purchasing a wire to a direct connection location, which is really a point of presence where major internet service providers exist. And in order to run that cross connect or that wire between your switch and their switch, they need to create something called the cross connect, because you can't just plug into somebody else's network because you can be a hacker. So what does this really mean? It means when you want to create a direct connection, what you really need to do is request something called a letter of authorization. And with AWS, here's how you do it. You go to the management console, the API or the CLI, and you request one. And when your application is complete, what's going to happen is AWS is going to provision the switch port at the direct connection location, and they're going to give your internet service provider the ability to run that cable from your switch to their switch. You download the letter of authorization, you send it to your service provider, and poof, guess what? Everybody's connected and you've got really good higher performance. Now, while we're talking about AWS public and private interfaces, your direct connection can take you multiple places, kind of like the old days in 1996 or earlier where we connected to the Frame Relay Cloud. And on that cloud, they could create multiple connections for us to go different places. Well, we can do the same thing with AWS. And we're going to have public and private interfaces. Now, public virtual interfaces are basically going to give you access to all AWS public services in the region for which your direct connection is established. Public services, DynamoDB, SQS, public endpoints. Now, what will happen is you're going to need a globally routable IP address on both sides because this is public. You'll exchange routing information over BGP, which is my favorite thing. And if you follow us on LinkedIn, you might get a BGP surprise that's really going to help you in your career. So somebody from my team can post a link to follow us on LinkedIn. Wait till you see, I got some real BGP training coming for you. You're going to love it. So you'll use BGP, you'll exchange your routing information. Now, when you're using BGP, you have to understand that AWS does not re-advertise your routes to anybody else, so you don't have to worry about becoming a transit autonomous system. Again, if this is a complex BGP thing. I spent more than 10,000 hours learning and mastering BGP. You can't obviously cover that in a couple hours. And AWS is a very, very, very limited BGP implementation. It's got minimal features and it only accepts a small number of routes. And that's true with any cloud provider. You got 100 to 1,000 routes. Many enterprises have 10,000 routes. The internet has 800,000 routes. So you're going to have to do what's called route summarization or route aggregation. So public interfaces take you to public stuff. So where do you think private interfaces take you? To your virtual private cloud, your virtual data center. And here you can use private addresses on both sides, but you can only advertise 100 routes, which is nothing. So your IP address planning needs to be critical. If you don't know what we mean by that, make sure you find a qualified network architect to help you design the IP address planning. Because if the IP address planning is right, everything's going to work smoothly. And if your IP address planning is bad, it's going to be a disaster filled with outages. So let's kind of look at what it means from a these perspectives with these virtual interfaces. You could do VPC. So let's give you an example over here. You connect your data center to the cloud, and they can create virtual interfaces. The public interface would take you to, say, S3, and a private interface would take you to your virtual data center, otherwise known as your VPC. Now, I talked a little bit about bundling performance. Now we're going to get into link aggregation groups. There is going to be times where 10 gigs is nothing and you need a lot more.
Hey, Mike.
Yes.
I have to be the ombudsman here. You've been going for about 25 minutes.
Okay, let's answer that.
Link aggregate. I know that's a new topic. So,
well, let's do this. I got about 3 minutes of link aggregation group stuff, and then but yeah, I was thinking the same thing.
All right, perfect.
So let's talk about link aggregation groups there for a minute or so. If an organization needs truly high availability or truly high performance, go back to my outage. 1 is none, 2 is 1, and 3 is greater than 2. Military outage, but it's commonly used in high availability systems as well. So let's look at it this way. Here's your single direct connection. Here's the second one. Here's the third one. Now, you put them together, it just looks like one big fat wire. That's what a link aggregation group is. And imagine how much more writing I can do with 3 pens than 1, because I got 3 sets of ink, right? Same thing with the link aggregation group. We've got, basically, here's what's coming in. 3 wires, 3 times the speed. Now, we can set it up where if 1 wire goes down, the whole thing goes down. Or we can have 4 of them in the link aggregation group, and if 1 goes down, we still have 3. And that's how we set up our routing based upon our performance and our availability needs. But it always comes down from an architecture perspective to business requirements. Always, always, always. But when you do a link aggregation group, they need to be the same type speed and latency. So if you need 40 gigs of bandwidth, let's say you put all 40 gigs on Verizon. Can we build a wide area network and a single internet service provider? No, that's insanity. That's why for the last 30 years, anytime it mattered, we used 2 internet service providers. So we could put 4 links on AT&T, 4 links on Verizon, 4 links on Vodafone, 4 links on NTT. It doesn't matter, but 1 is none, 2 is 1, is 3 is greater than 2. So we need multiple service providers when we do this. Now let's look a little bit about this. Let's cover this. So by default, a link aggregation group will stay up as long as any one of your connections. So let's say you got 3 here, 1 falls off because it goes bad, it'll still stay up. But if you had a 40 gig primary link and a 40 gig secondary link, and you wanted, upon failure, the main link aggregation group to go down, you can do this for high performance environments, but it's not standard environments. We'll go to questions in 2 minutes or less. So showing you, here's an environment where we have 2 link aggregation groups, a primary going to 1 direct connection location, and a secondary going to a secondary direct connection location. There you go. Link aggregation groups set up in a high availability environment. Now, Chris from my team is 100% right. We are definitely due to go some questions. Actually, before we get to that, if you haven't liked this content, please like, and please subscribe and hit the notification bell, because we have so many great things coming towards you to help you in your career.
You heard that, everybody. There's 700 plus people on here, 355 likes. I think we can get a few more likes, and definitely make sure you hit that notification bell so that you get notified each day the rest of this week when we go live. In case you're like me or Mike and you've got a lot of things going on, you might miss out on that notification. So hit the notification bell. So Mike, I know we're not going to take any career questions, but I just want to let you know we've got some nurses out there.
Welcome, nurses. I love working with nurses. I was a nurse before I became a nurse practitioner practicing internal medicine. Healthcare with the communication skills, emotional intelligence, and empathy is a great, great background, especially the way we ask questions for any technology career. So welcome to the nurses.
Yes.
Just and thank you for your service.
All right, so let's get to some questions. I collected some during the presentation that I thought were relevant. Here we go.
What are direct connection alternatives, if any? Well, VPNs, direct connections, or software-defined networking, or something called SASE. I'm going to go over the software-defined networking and SASE for a minute, even if we run a couple minutes longer on the questions, because I think it's probably valuable to describe them. So, as I previously mentioned, internet performance is unguaranteed, and it's relatively slow. So what we can actually do is we can enter the world of software-defined networking, or SD-WAN. So what happens in the SD-WAN is, normally the routers actually hold the intelligence on how to get through the network, but they only know what they know. So a software-defined networking solution is basically a truly enhanced VPN. So let's say you've got a router over here, and you've got another route. Oops. I don't know how I did that, but that's okay. We're just going to work with it. And another router over here. And typically speaking on the internet, it's going to look like this. You're going to have a bunch of these little routers, and they're going to be everywhere, and they're going to be connected to each other. And on the normal internet, BGP is going to give you this path. But with software-defined networking, what you have is you have this pie in the sky, this SD-WAN. It's kind of like a satellite that looks and sees everything. And it tells each routers, how do you send the traffic? Maybe, for example, this is the fastest path to the destination, over the top. Or maybe the top links are congested, and they should go to the bottom links. And the bottom links could connect you to the top. And that's what SD-WAN is. It uses the internet, and it uses a greater level of intelligence to tell you how to get to the destination. So that is your basic option 2, SD-WAN. This is much newer. And the alternative is something called SASE, which is really more of a networking as a service. And there's lots of good SASE providers out there. Versa Networks is incredible. It was founded by Kumar Mehta. I know him personally. He's a genius. He and his brother are Harvard, 2 IT graduates, have their own company. John Chambers is an investor in Nile, which is networking as a service. Aviatrix also provides networking as a service, another SASE environment. And basically, I don't have enough time to cover this because, I spend 8 to 12 hours discussing SASE normally to my networking people. But basically what happens is you connect to another service provider. And then once you connect to them, you basically ride a network to the end. And basically it's giving you similar to private line performance because you're connecting to a provider. And then that provider connects you from your source to your destination in a highly secure environment. So they're the other two. Great question, by the way. I'd love to ask that question. Ganesh, if the public internet is down, the VPN will not work. Exactly. And there's much more to go wrong on the internet than there is on a private line. What's the difference between a VPC? A VPC is your virtual data center. A VPN is a way to tunnel traffic through the internet. Completely different, but good question. And I'll cover the VPC in real depth. Now, I know the reason you asked that question is there's some course providers that are teaching AWS courses that have never been cloud architects or network architects before, and they like to call your VPC a virtual private network. It is not. It is a virtual private data center, but we'll get to that in real depth. How is the tunnel different than an internet connection? You got the internet, and then you shove your data inside of a tunnel on top of it. So you still need the internet connection. The tunnel is where you stick your traffic inside of the internet connection. Good question, Igor. When you have 2 VPN connections in a firewall in a data center, initiated from data center through BGP to choose your best path using BGP output. Mohammed, We have to do that. That's way beyond what I can cover in here. I do have something coming for you as a real surprise. If you guys follow me on LinkedIn, you'll be able to download it real soon. That's going to teach you BGP in a very detailed manner that's going to help you understand this. But, you know, whether you use the weight, the local preference, the AS path, the origin code, the multi-exit discriminator, that's up to the network architect or the cloud network architect, or even the cloud architect to know which to choose. And that's going to be a lot. Here's a question for you guys. We're going to do a poll. Would you like me to do a fun BGP workshop and give you an incredible BGP document to help you in your career? If so, let us know. Type hashtag cloud networking in the box. And if we see lots and lots and lots of them,
I'm actually going to do a poll, Mike.
Oh, okay. I didn't realize we could do these kind of scientific things on YouTube. I got an incredible team behind the scenes. But I still like to say it in the chat.
We just put that poll there in the chat box. Do you want a BGP workshop? Let us know. Make sure you take part in that poll. If we don't get enough people that are interested, I'm not going to be able to do it. So if you're interested, make sure to let us know.
And I need to see about 200 or 300 cloud networkings in the comment section below. I get happy with comments. SD-WAN is essentially a load balancer. No, a load balancer is a device that automatically shares your traffic between servers. Completely different technology. But we will talk about load balancers in depth, and we'll get into some things that we have coming out. We'll get involved in some traffic engineering with BGP. All of it. It's all kinds of fun. Like I said, I spent over 10,000 hours with just BGP. Mufaz, I know Mufaz is incredibly smart. He's one of our students. Does a direct connection from a data center to the cloud use the BGP algorithm when deciding which path? Absolutely. Anytime you use BGP, it follows that. Great question, Mufaz. Will point to be deployed for the tile? It depends how you set it up. Do you want to do a point-to-point tunnel? Do you want to do a multi-point tunnel? Or do you do multiple point-to-point tunnels? I'm seeing people are looking for cloud networking BGP. I love cloud networking BGP, but please, seriously, follow me on LinkedIn. We have a surprise that's coming for you next week that's truly going to be helpful to you. And I'm going to be distributing that on LinkedIn.
And of course, just to let everybody know, if you asked a question about a topic that we haven't discussed in this section, we won't be taking the question. I saw some questions about object storage and things like that. Saw some questions about securing systems, and we haven't covered all of that yet. So we'll be covering those later in the bootcamp.
And what is a cloud, everybody? It's a virtualized network and a data center, which is why if you don't know the network and you don't know the data center, you can never be a cloud architect because you can't design what you don't understand. Can you deploy a VPN as an isolated channel for network service disruption? I don't know what you mean by that. If you can translate that to me into something a little simpler to understand. And I've been dealing with networking forever, but I don't know what you mean by service disruption. Okay, well, I'm seeing lots and lots of cloud networkings, which is making me happy. Any more questions for me to get to, Chris, or should I go back to the content?
I'm going to give that one that you asked for clarity. I'm going to give them just a second to see if they can give us some clarity.
But there was a very perceptive person in there that says, I need to know networking. Yes, that's why I answered it that way.
Yep, there it is. That's
so, Nelly, absolutely. Networking is critical. Here's what happens when you don't know the network. And how do I know? I spent 20 years fixing it. Everything falls apart. The network is the foundation. Which is better as a backup, a VPN or SD-WAN? SD-WAN is a much better performance solution. But like anything else, Anakin, there is no such thing as the best technology, ever. What technology solves the business problem in the best manner? That's the right technology. That's why serverless advocates and cloud advocates and network advocates have no place in any business. You should never listen to them because they're like a hammer in search of a nail. When you're a hammer, all you want to do is hammer nails. An advocate has a fondness for technology. an architect, like a cloud architect, enterprise architect, or a really great cloud engineer, guess what? They don't have a favorite for any technology. Their favorite technology is the one that makes that business better. And every business has different business challenges, and the favorite technology is the one that works that time. And on the next customer, guess what? They've got another thing. Business sees first, always. Yes, I'm not
There we go. That's what there's your clarity.
VPN is a failover. Absolutely, VPNs are almost always used as a failover. I would, if it really matters, I would do direct connections, backup direct connections, and VPNs. Absolutely. And heck, I would usually use 2 internet service providers on the customer side running BGP to the internet. And that way we could also, if either one of the internet service provider fails, our backup still comes up. So great question.
All right. So yeah, it's time to get back to the content, but there's a couple of things. I've only got 295 votes and there's 685 people watching right now. So not even half the people have voted if they want a BGP workshop. So make sure to vote. Let us know if you want a BGP workshop. Also, 688 people watching now, only 496 likes. So if you've liked this, or if you watched it a little bit and you like it, give us a few minutes. See if you like it. If you like it, hit the like button. Make sure to hit the subscribe and the notification bell so that you don't miss out on any of these. And if you vote for a BGP workshop, make sure to hit the notification bell so that you get notified when we do the BGP workshop. So
yeah, and let me get to one last thing. Thank you, Chris. I don't ever recommend anybody take a Networking Plus course. It's too basic. But we do, Ebony, have a completely free CCNA course, which is a basic intro level course. It's about 5 times deeper than the AWS Advanced Networking, and it's completely free on our website.
I'd like to follow up with that you are actually in the right place, not the wrong place. If you need, if you're needing some networking. So you are in the right place, Ebony. Keep it up.
And we've got lots of free networking things on here. I've been teaching networking since 1996 while working in networking, or 2000. I taught it to the people at WorldCom. I taught it to the people at Riverstone Networks, now Nokia. I taught networking to people at Cisco when I was a lead architect at Cisco. So I've taught networking to others, and I love it. So you're in the right spot. So let's talk about storage. Look, we're going to have all this compute power. We're going to have all this networking things. We're going to collect data, right? Now, what do we do with this data? We got to store it somewhere, right? If we have no storage, we've got nothing. So now we're going to get into storage. And I love storage because that's where you store your stuff. And I've got a lot of stuff. Like data-wise, I've got a 96 terabyte RAID array sitting in my house. So I've got lots of stuff to store. Businesses have petabytes of stuff to store. So now we're going to talk about storage. So to begin, before we get into concept, what is storage? It's the place where you keep your stuff. So it's really an environment to keep your organization's data. Now, when we talk about storage, we're going to talk about 2 different kinds. We're going to talk about volatile storage and non-volatile storage. So what is volatile storage? It goes away when you terminate your system. So imagine your computer has DRAM or memory in it. All the stuff's in memory and you reboot your computer. That is volatile storage. It's not there after the reboot. On the cloud, we'll get into virtual machines. If you store something on the virtual machine itself instead of a different type of storage, block storage, which we'll talk about later, and you terminate that computer, guess what? All your stuff is lost. That's volatile storage. Other people might call it ephemeral storage. Google likes to call it ephemeral storage. I think Azure calls it ephemeral storage too. Same thing, stuff which goes away. Non-volatile storage, think your hard drive, right? That's why when you buy like a PCIe network card, they call it an NVMe, non-volatile memory express. It's basically because it doesn't go away with reboot or instant termination. Storage is a critical part of your environment. Now, we're going to be dealing with 3 different kinds of storage, and the 3 different kinds of storage that have existed in data centers for decades. So when you hear this stuff, it's not new. I've been working with it since the late 90s, and it existed a lot of this stuff even before. So we're going to begin with a little intro of block storage, And then we're going to get into, just so you know what it is, block storage is a type of storage area network, which we're going to use as virtual hard drives. We have our data, it's broken down and placed into blocks. And why do organizations and cloud providers use block storage? I'll get into it in much more depth when we call our block storage volumes, but just an overview of the technology before we get into it is as follows. I can have my server here, I can have my storage over there, and as long as there's network connectivity, I can access that storage. So it's super awesome. So block storage is typically used as virtual hard drives in your RAID arrays. It's used in your data center if you're using Nutanix, IBM OpenStack, VMware, or any other environment. Any of you guys that have worked in technology for a while and you saw all those fiber channel networks, a lot of that was related to block storage. So you take the data, data's down, broken into blocks. Now the next type of storage we have is object storage. Now object storage is where we take our data and break it down into objects. And we'll get into the fundamentals of each and more when we get to the concepts itself. Now object storage is very unique storage. We take our data and it becomes an object. Now, what's cool about object storage is with object storage, every time we store something as an object, it's got something called metadata. Metadata. Who makes up these words? What does metadata mean? It's information about your data. So we all saw my beautiful cat Cindy before, right? In that example we used. So let's say if I've got about 10,000 Cindy photos, and believe me, I do, because I love my cat. I need to know which one is which. So I might say Cindy as a newborn, Cindy catching a lizard, Cindy sleeping on my pillow, Cindy rolling around like a cat. And I might want to label that information so I could find the right photo, right? Well, with object storage, our data gets broken down. And it gets stored as an object with data about the data so we can find it. So now we're talking about really cool stuff, big data environments, and we'll talk more about this as we go through. It's that metadata which makes it so useful. What we need to understand right now with object storage is as follows. Anytime something changes, and we're going to show this much more later when we go through the things themselves, it creates a new version. So we can't use object storage and connect it to a computer. We cannot. But it's perfect for static website hosting, for example, and other things, etc. Keep that in the back of your mind. So can't be used and mounted to a computer, and we can talk about later. And then the last kind of storage is called file storage. Now there's basically two kinds of file storage. Like the hard drive in your computer is file storage. Or maybe you've set up a file server, or you've done on your computer, where you take a Windows computer and you share your C drive, D drive, E drive, or whatever, and poof, other people can access it. That's still file storage. Or maybe you're a Linux systems administrator or a Unix systems administrator, and you set up something called an NFS share. That too is file storage. So file storage is local to the computer, physical hard drive, or network storage that's attached either by the server message block for Windows systems or the NFS file system, which is actually used by Unix and Linux systems. So now that we covered it in basically these two data center storage technologies, let's talk about the AWS proprietary object storage. And I want you to know, object storage is nothing new. Every cloud provider has it. AWS paid their marketing people millions of dollars to come up with the name Amazon Simple Storage Solution, which they call S3. Microsoft calls this stuff Blob. Google calls it cloud storage. It's the same. It's like if you needed a brick and you had a choice to go to Home Depot, Lowe's, or anyone else. It's the same. Keep that in the back. So when we're dealing with object storage in the AWS platform, they call it S3. If you ever talk to a customer, don't call it S3. They won't know what it is. They'll escort you out of the room. But if you call it object storage, the chief information officer will know what it is. And AWS object storage is integrated into almost every AWS service. It's relatively high availability at 99.99% available, should things go well. And what does that mean? It's going to be available basically all but 52 minutes per year. Not bad, not great, not super high availability, but moderately high availability. Now, the durability of AWS S3 is great. What does durability mean? Even if you can't access it when you need it, the ability to keep your data and not lose your data with AWS is exceptional. In fact, it's 99.999999% all the way to 11 places. So basically, that's how. So basically, if you store your data on AWS, it's near impossible for you to lose it. Although I'd still back it up to another cloud just in case. And let's talk about some use cases. Why would you use this object storage? Well, you might use it for backup on archival purposes of an organization's data. You might use it for static website hosting. You might use it for distribution of content, say media or software. It's great for disaster recovery planning. You create images of your virtual machines, back up your data stored on object storage. If you're on AWS, don't back up to the AWS cloud, back up to another cloud. If you're on Azure, don't back up to Azure, back up to another cloud. Don't use another region, use another cloud. And object storage is great for big data. Why? As I mentioned, we take our object, our data, we break it down into an object, and we have that metadata, or the data about the data. As I mentioned, we could have something that talked about my cat named Cindy. And when we talked about my cat named Cindy, we could have Cindy rolling around on the ground, Cindy chasing a lizard, Cindy cleaning herself or grooming herself. That's the metadata. Because object storage has metadata, it works beautiful in big data environments such as data lakes. So let's talk about the implementation AWS. AWS is organized into buckets. Each bucket is a container for your files are stored. Buckets are going to create like a top-level domain space, meaning every time you create a bucket, it has a globally unique DNS address, just like a web browser, which is really nice. Now, you can give these bucket names up to 63 characters in length on AWS, numbers, hyphens, and periods. Now, that's going to give you something that's going to basically make it look and feel like file storage, but it's not file storage. Just because you use delimiters and make it look like this/this/this doesn't mean that on the technology itself, that's how the data is stored. Object storage realistically is like a giant database where the data gets stored, and there's a little pointer where the data is. It's flat. So you're going to create a bucket, but that's for you. It's for we humans to manage it. It's not the way it's actually working behind the scenes. So keep that in the back of your mind. You can run SQL queries on your data because of that metadata, and an organization can have up to 108 buckets per account. And if you need more than 100, you just contact AWS support and they'll give you another one. So S3 buckets, specifically our object storage in AWS, are the cause of 16% of all hacking events. 16%. It's crazy. Now, it's because everybody learned how to configure, which is very simple. We've got labs for you to do the configuration. And also, every time for you engineers out there, architects don't touch the tech ever. We design, present, and sell it. Cloud engineers do build it. Cloud admins build it. Even DevOps engineers touch the technology. Architects do not. We deny, design, present, and sell. And 16% of all attacks are occurring, not because somebody doesn't know how to know what to configure. It's because they know how to configure. It's because they don't know what to configure. So every time, I'm going to tell you, every time you want to go configure something, go to the documentation on the website. Reading 5 minutes of documentation will save you 5 hours of troubleshooting. And any of us that have been around a long time don't do it on our heads, even though we do it every day. We always go to the documentation in case a version changes, and it always changes. So how do you secure your data? Well, you could use a bucket policy, and that's, the preferred method because it's pretty granular. You can base it upon an identity and access management concept, meaning who are you, what are you allowed to do, and keeping track of it. Or The non-preferred method is to use an access control list. Now, it's not the kind of access control list you would use on a router. It's like an IAM access control list, like read, write, or full control that you would see on a Windows or Linux storage. Now, when we talk about object storage in AWS, look, it's all on the same underlying technology, but they have multiple storage classes. Each storage class has different performance standards and different financial metrics. And we're going to cover AWS S3 standard. We'll cover S3 and frequent access. We'll cover S3 and frequent access one zone. We'll cover S3 intelligent tiering, S3 Glacier flexible, and S3 instant retrieval. So let's talk about S3 standard. This is your standard object storage on AWS. It's relatively high availability at 99.99% high availability. It's high durability at that 11 nines durability. It's relatively decent performance. And this is what you're going to use for your frequently accessed data. Now, when you use this, it's the most expensive form of storage as a rule. But if you access your data frequently, this is your choice, because you're not going to pay to retrieve each time you need to retrieve your information the way you would with some other types that we're going to talk about. So got lots of data, stick it on S3 standard, traditional object storage. Now, what if you wanted to pay less and you didn't use your data that much? Now we're getting into S3 and frequent access, which has got high availability, same as before, high durability, same as with primary S3, relatively good performance, same as with S3, but you pay less. But every time you want to pull your data, you pay for it. So you actually pay less to store it, but more that you pay to use it. So that's why I said S3 standard access, use it frequently, store it in S3. S3 and frequent access, used for stuff you're not going to pull very frequently. Now you can get your data when you want, but you're going to pay to receive it. So it's like anything else in architecture. What are the business requirements will help you select the right thing. Now here's where it gets a little fuzzy. I don't like this at all. We have S3 standard and frequent access one zone. Now we're talking about storing all your stuff in a single data center, which is fine for my website, mycatcindy.com. I don't have that website, but if I did, I'd store it in a single data center because it would just be photos of my cat. But if it really matters, you can't have your stuff in a single data center. Now, when you use S3 and frequent access, you've got reduced availability because it's nothing to take one data center now. But you pay less for it. So, and you still pay for data retrieval, but it's instantly available. So if you've got data that you don't need to reach instantly, it's great because you still have the same durability. You'll get your data. It's just a matter of whether it's going to be available when you need it. So depends on the data. S3, data you're going to need frequently. You're going to access frequently. Infrequent access, data that you may need urgently, but you pay to receive it, but you pay less to store it there because you're probably not going to use it. S3 and frequent access one zone. Data that you probably won't need access to that often. And if you do, it's not critical if you can't get it for a couple hours. Now you know which of those to use. How about S3 intelligent tiering? This is the automagic stuff. I hate automagic. It never works the way it's supposed to. Why do I call it automagic? Because AWS machine learning technologies are going to evaluate your storage at all times, and they're going to move it to whatever it thinks is cheapest for you. Maybe great, maybe not. So I don't ever like the fox to garden my chickens. AWS's best interest is for you to spend as much money as possible, like the fox wants to eat the chickens. Your goal for your customer is to spend as little as possible to get the maximum results. Intelligent tiering is the business to trying to sell you something, managing the results. So they manage your data and they move it to the cheapest platform for you. At least that's what they say they do, managed by AWS. And if you don't know anything about your data or your data patterns, it's a good choice. Now let's talk about Glacier. What is S3 Glacier? It's still object storage, right? but it's for long-term storage that you're probably not going to receive. So what are we talking about over here? We're talking about long-term storage. Now, S3 Glacier is 68% cheaper, according to AWS, than S3 Infrequent Access if you don't retrieve your data for 90 days. But if you retrieve their data, there's a much bigger fee. It's all how you're going to use your data. Now, there's traditional Glacier, which they now call Amazon S3 Glacier Flexible, and this is really good for data archive purposes. Now, you have something called a vault lock option. So let's say you're in the banking industry or the healthcare industry where you got to guarantee that the information has not been modified. And for people like me that have designed healthcare banking architectures, for example, a bank purchases 100,000 shares of Cisco stock. And then the SEC comes in, they need to see that transaction. So Vault Lock offers an immutable option for S3 where you can make it that it's locked and frozen, that nobody can change the data. Very good for businesses that have high regulatory environments like banking and healthcare. Now, S3 Glacier Flexible is designed for information that's accessed 1 to 2 times per year. You can get your data in minutes to hours when needed, and it's low cost. It's even 10% less than Glacier Instant Retrieval, which we just talked about. But you pay for your data and you must request it when you need it. Now let's talk about the cheapest option. This is called S3 Glacier Deep Archive. No, this is good if you need to access your data in 12 to 24 hours. It's designed for information that's not accessed more than once a year. Your data is stored in 3 data centers or availability zones, but it's really designed for long-term storage, 7 to 10 years, regulated industries. So let's talk a little bit about lifecycle management. So lifecycle management is really good when you want to optimize your storage costs. So let's look in this example at some lifecycle management. Here, what we can do is we can create a policy where the stuff or the data we need to use frequently, we can keep on S3. We can automatically tell our data to move to infrequent access over, say, 30 days. And after 30 days, go to Glacier or long-term storage. So why would we do this? Let's say we're a magazine. Excuse me. And in the magazine, our data, we post a new article. Let's say that article is accessed almost all the time for 30 days. We put it in frequent access. And then after 30 days, almost nobody views it, but we want it to be accessible, interesting. So we keep it in S3 and frequent access. And then after that, almost nobody's ever going to use it. So we could say stick it in Glacier Instant Retrieval, lower the cost for long-term storage of our data. I'm going to talk about a few more S3 concepts. Now, if you'll recall, I talked about every time with object storage, you make a new version of something, which is why you can't mount it to your hard drive. For example, on your hard drive, you have something called the swap file or your virtual memory file or your page file in Windows. It's typically 1.5 times the DRAM. So a system that's got 4 terabytes of DRAM, which is nothing for the kind of servers I work with, would have a 6 terabyte swap file. Now, that swap file will be modified, say, 1,000 times a minute, which means if you used object storage, you would have 1,000 6 terabyte objects per minute. Clearly, that would fill up the storage arrays, and you'd be paying, millions of dollars a month for just nothing. So we got to keep that in the back of our mind. That's why you can't use this. Now, with object storage by default, it creates millions of versions. You write 20 Microsoft Word docs called CSA, and guess what you're going to get? You're going to get 20 of them. We're going to get, for example, a CSA doc, and I'll have a key number, 147, 148, 149. Every time you save it as a new version, you're going to get another one. Now, normally, this is by default. Now, AWS knows that 90% of the population doesn't want to pay for 18 million versions of something, so they auto-delete older versions, unless you turn on S3 versioning. And when you turn on S3 versioning, it goes to the default behavior of object storage. Every time an object is modified, guess what? It stores a new version. And by storing a new version of that object, we've got backup. So imagine having 50 versions of a book that you just wrote. All of a sudden, version number 267 gets corrupted. you go back to 266. And by doing so, you've got the oldest, best copies. It's great for environments, but it gets much more costly because you've got a lot more data. Now, I'd like to briefly talk about deleting your data. So this morning, I woke up to no cable TV. Why? Because my cute cat pulled out the wires behind my TV while I was sleeping. She does this, and he's like a little, she's a great troubleshooting coach. And imagine you go to delete a file and you delete some really critical file. Not the greatest thing in the world. Now they have like a recycle bin on all the cloud providers, but they didn't used to. But what you can actually use is multi-factor authentication to delete things. So I go to delete something and then say maybe it sends me a text message. Are you sure you want to delete it? And I say yes. Multi-factor authentication delete. Well, what if a hacker tries to delete something? The hacker sends it, an MFA challenge is sent to the administrator or the owner of the data, and the owner either says, yes, I tried to delete it, or no, I didn't. So let's kind of walk through that as it pertains to securing your data. One is, let's say somebody like me tries to delete my data that's on S3. I'm now sent an MFA challenge where it's asking for a one-time password, which usually comes from like an RSA Secure ID or a Google Authenticator or whichever option you choose to use. And from there, I provide the one-time password and then the object's deleted. Hacker does this. Hacker tries to delete something. I get sent a challenge. I say, no way. I don't provide the password and the object is still there. So it's an additional way to secure your data. So let's talk about organizing your data. It's not traditional storage. As I mentioned, it's organized like a database. You've got flat storage inside of a bucket. There's a pointer to the data. And you can stick a delimiter in there to make it feel like Mike/2020/AWS video/storage/s3.mp4. And it kind of looked like a Unix file system, but it's not. Flat storage, database pointer to the object. Now, let's say somebody breaks into AWS and they steal those hard drives where my data is on. Is that a problem? Well, it depends on how your data is stored. If you store your data in raw format on the hard drive, yeah, you got a major problem because somebody just stole your data. If you encrypt the data, it looks like gibberish unless you've got the decryption key. So you should always encrypt your data on S3. Encryption is going to make your data unusable without the encryption key. And we can encrypt it on the client side or the server side. So let's do this. So let's talk about some of the encryption strategies. There's server-side encryption with the key management system. Basically, what happens is a complete key management solution. The user manages the master key, and the key management system manages the data key, and the key management system provides an audit trail of how, who, and when your data was accessed. So, for an example of what these keys look like, in this environment, we've got our key management system, we've got the customer master key, we've got a data key, and we need this key to actually decrypt our data or see it. Now, another option is if you want basically completely automated. Now, as you go automated, you lose flexibility, is the SSE-S3 AWS Managed Keys. And this is a total complete management solution. So the keys are all managed. Data is managed, all the keys. So the keys are automatically rotated and every object is encrypted with a different encryption key. So great automated solution, but you don't own it, which means if there's a hacker that gets into the AWS environment, they can attach your system. So truly secure systems, you're going to manage these keys. You're not going to let anybody else do it for you. What's that look like? In this case, we use the AWS Key Management System, SSE-S3. And yes, this could be on your test. We've got a master key and a data key, and it's all managed by that system for us. So it's automated. And I know we're getting in some deep, ugly stuff here, but as part of the certification, you really do need to know this. Now let's talk about the SSE-C or customer provided keys. So now you're dealing with a bank or a government entity that needs complete autonomy over their own customer keys. The customer manages all keys. So, highest security environment, but it's a lot of maintenance overhead. See, the customer controls all keys. So let's talk a little bit about optimizing S3 for performance. Actually, before we do this, Chris, how long have I been talking?
About 25 minutes.
Okay, let's take some questions because there's a lot of storage content to go over. Is ephemeral storage good for caching and queuing? Generally speaking, ephemeral storage is used for caching. Now, if we use it for queuing and the system were to reboot somehow, we might actually lose it. So generally speaking, for caching, yes. For queuing, I might want to store it on non-volatile storage. Can you use block storage in the cloud? You must use block storage in the cloud when you want to connect to virtual machines and you want your data to be there. So yes, you can. Good question, and we're going to cover a lot of that. What is network storage? Well, network storage is any storage that's attached over that you can access over a network. So network storage could be block storage, object storage, or file storage, because they can all be accessed over a network. Good question, Igor. Serene there, what is SD-WAN, please? We actually covered it a little bit about 45 minutes ago. Traditionally speaking, what happens, the routers have the control plane, which is the routing protocol. They use an interior gateway protocol, which is typically OSPF, or intermediate systems to intermediate systems in today's world, by the service providers. And then they run BGP to connect to external entities and carry externally learned routes across their autonomous system. And the knowledge is typically located on those routers. SD-WAN, as we showed, is basically you've got it looks like it's called the controller, but basically it's like a satellite in the sky that looks for congestion all over the internet and determines that it's going to how and where to send the best traffic. Does AWS support automatic replication of resources across clouds like Google, or does it have to be managed by cloud engineers? I don't know what you mean by that. It automatically replicates across their cloud, their own cloud, but single cloud, single point of failure. If you want to replicate across clouds, you're going to have the cloud engineers are going to have to use a synchronization service or something like that. Sarah, what's the difference between intelligent tiering and lifecycle policies? Excellent question. Lifecycle policy is you know your data and you know exactly how the company uses, and you manually set up the policy, meaning there's engineering behind it. Intelligent tiering is Amazon does it for you, and you hope they pick the right things for you. It's done via machine learning, which may be great, maybe not. But remember, the more you pay, the happier they are. So it might be better to be able to do it yourself when you actually know what's going on. What is the default behavior? I don't know what you mean by that. It's object storage, so the default behavior is to behave like object storage in any other data center or cloud. If there's something different that you mean about a specific thing, Karen, let me know. S3 is typically to your region, but you can set up something called multi-region replication, which I'm sure we'll talk about soon. Good question. What's the name of the storage that's 10% cheaper than Glacier? That's Amazon S3 Glacier Flexible. It's 10% less than Glacier Instant Retrieval. So SCSI is actually related to a hard drive connection cable. iSCSI is a means to actually mount remote file services over an IP network. And iSCSI is typically used with file storage. What are the object alternatives that AWS manages? I don't know what you mean by that question. I'm sorry, Willigan. What is block storage? We'll be covering block storage after this. And yes, you need to understand it for a certification. And here's the reality. You can pass a certification and still know nothing. I want you to know it well. That's why we're focusing on the concepts. And you won't be able to do any job on the cloud if you don't understand block storage. So yes, we'll definitely talk about it. And you need it for the certification too. Network attack storage versus storage area network. They're kind of one of the same. There's some subtle differences. Network attack storage can be block storage or file storage. Storage area network can be block storage or file storage. Here's the key. They're both accessed over a network. Now, many storage area networks are covered or connected via fiber channel, whereas most network attached storage is covered via IP, but very, very, very similar. Igor will be discovering IOPS in depth once we start covering block storage. Okay, so let's go back to the concept. And when we go back to the concept, let me just find out where we are. Let's talk a little bit about tuning S3. And then once we get to this, when we get to block storage, we're going to have lots of fun. Please follow us on LinkedIn before we begin the concept. I'm telling you, we got a massive surprise for you coming next week. I want everybody to take advantage of the surprise. We've got major articles that we publish from major magazines that we distribute over there, everything from Forbes to Information Week, etc. So kind of to Tech Republic, and we put all of that over there on LinkedIn. So please follow us. But next week I got a serious supply for you. And yes, we're going to be doing the BGP workshop since over 500 of you volunteered. That was my minimum of 500. Please like and subscribe to this channel and hit the bell because we've got a lot of things. You know, we've got a lot of people coming on and only 600 likes. Help us out with this a little bit. Keep the algorithms happy. And follow us on LinkedIn, and we're going to share the details of that BGP workshop right there. So let's talk about tuning S3 for optimal performance. In this section, we'll talk about pre-signed URLs, multi-part uploads, range gets, and cross-region replication, which is going to answer one of the questions that someone just asked. Let's start with pre-signed URLs. When you store your data in AWS, it's going to be private, okay? Which means nobody's going to be able to access it. So you need to enable access. Now, what's the simplest way to do this? Pre-sign your URL, which is basically where you sign a link to the file with your own encryption key. I'm sure many of you have done this with Google Drive, for example. And it's going to provide temporary and secure access to your desired content. Now, how you sign the URL has a lot to do with how long it's accessible. So, built this table to help you. If you use your IAM instance profile, we'll talk much more about identity and access management later. It's good for up to 6 hours. If you use the AWS Security Token Service, which of course we'll talk about later, which is much more secure, your data will be good for up to 36 hours. If you sign in as an IAM user, it's good for up to 7 days. And if you issue a temporary token, it's good until the token expires. So the next part is something called multi-part uploads. So S3 allows you to upload files of up to 5 gigabytes. Now S3 will allow you to store, I believe it's a 5 terabyte file on object storage, but that's a big difference between what you're allowed to upload versus what you're allowed to have in, say, a backup copy of something. So kind of keep that in the back of your mind. Now, when you try to transfer a 5 gigabyte file over the internet, and believe me, I do videos, I do it every day, it doesn't always work the way you want. See, internet performance is not guaranteed, and a lot can go wrong when you're trying to transfer a large file. So AWS wants you to use a multi-part upload. What's a multi-part upload? Well, A multi-part upload is as follows. You take your file, let's say it's a 5 gigabit file, and you split it into a bunch of little mini files. And then each file is sent, and then it's reconstituted on the far end into a big file before it's stored in object storage, or otherwise known as AWS S3. Now, let's say you've got 4 parts of the file. What if file part 1 at the top and the 2 at the bottom get sent, and the second one from the top gets missed? Guess what? All that'll happen is you'll retransmit the data that got lost, and everything else will stay there. So this is a beautiful, beautiful system, and we love it. Multi-part uploads. Send multiple separate streams. When it gets constituted, if any one stream gets lost, you send it. Now, how is this different over normal? Normally, you send a 5 gigabyte file, and if it gets lost, you got to resend the whole thing. So this is much more efficient. Now, someone also asked about, does AWS send your data all over? Well, let's talk about cross-region replication. Let's say you're in the US and you wanted to back up your data to Europe. Let's say it's a static website, for example. Now, in normal networking, you pay to build the network, but you don't pay to use it. But with cloud networking, you not only pay for your network connections, you then pay a daily fee for the connections, and then they actually charge you to use the connection that you actually bought from somebody else. Very much more expensive. And if you've got a website, and the cloud provider will also charge you to transfer your data between regions. So for a website, it might be cheaper to replicate your data across regions. And that way, people in the UK, for example, don't have to traverse the Atlantic Ocean to access the same data, which lowers the latency, and it also decreases your inter-region network transfer charge. So that's cross-region replication. It also is pretty good because if the US has a catastrophic outage, you can hope that the data in the UK would still be there. So that's why you could do cross-region replication. Now we're going to talk very quickly about instance storage. What's an instance? I hate this term. An instance just means a virtual machine. Same virtual machines we've been dealing with for decades, they now call instances. I have no idea, but that's the marketing. So when you're dealing with AWS, every virtual machine does come with its own little bit of storage. Everyone does. But here's the problem. If you delete this virtual machine, all the information stored on the server is lost. So you realistically can't do that. So the only thing that you're going to have on the instance itself is basically your operating system and your applications. Everything else is going to have to be attached and stored via block storage so it doesn't go away. Which brings us to, guess what? Block storage. Now, all cloud providers use block storage. And whether you call it a managed disk on, I think Azure, what they call it a managed disk, or AWS calls it elastic block storage, it's the same block storage we've been using for decades. Strip away the multi-million dollars spent on marketing names, and we all have the same thing. So let's talk about elastic block storage. They're going to call it high performance block storage. Block storage isn't high performance any way you shake it, and we'll go through some examples. Block storage acts like a virtual hard drive, but here's the key. It's not in the computer. It's somewhere else attached via the network with IP connectivity or fiber channel connectivity. You're typically going to use it on all your virtual machines. You're going to use them in your databases. Now, block storage is very scalable. Why? You can stick it anywhere. So you run out of hard drive space on one, you just add another RAID array or more hard drives, and you can mount them over the network. It does not go away when you delete a virtual machine or terminate a virtual machine. And it's typically used for mission critical use. And it is relatively high availability at 99.999%. So that's good availability storage. Of course, the cloud's not 99.999% available, or at least they haven't been for the last few years, but that's what they'll tell you about the storage. This is optimal for high throughput and high transaction workloads. And we're going to have multiple performance options. Now, in order to do this, your block storage is going to be in a single data center because it's got to be close to you if we want low latency. And it's automatically going to be backed up to another data center, otherwise known as an availability zone. Now, when we're backing up block storage, it typically does so in the form of a snapshot. What's a snapshot? Well, on your hard drive, typically speaking, you've got your operating system and its files, you've got your applications and its files, the user storage, all these files. Bunch of files. By comparison, a snapshot is an image that replicates exactly your hard drive, which can be reconstituted to a brand new server. So what it really looks like is this. You got your virtual machine, otherwise known as your AWS EC2 instance. This is attached to your Elastic block storage, which is a standard block storage with the name Elastic there for marketing purposes. And you can create a snapshot, which is a backup of the entire drive. That's all it is. Okay, so now we're getting into some storage environments. Now, I'm going to tell you right now, block storage is pathetically slow. And when it really comes to being an architect like me, one of the biggest problems you're going to have to deal with is block storage performance problems and how you're going to get through that. So after we touch the EBS, I'll actually teach you something that's much more complicated, how to work around the problems. You wouldn't find that in the associate. You barely touch it in the professional, but you're going to need to know it in reality. So we're going to cover it anyway. And when we look at our storage environments, we're going to be looking at the following: throughput and latency. Now, what are those things? Because, those things themselves are pretty critical information, things that you need to understand. And let's talk about what those kind of things really are. So imagine you have two cars. You got a Ferrari over here on the right side, real fast, 0 to 60. And on the left side, you got a giant tractor trailer. From 0 to 60, it's not super fast, but it can carry a lot of stuff. So now, they leave my house in Port St. Lucie, Florida, both the Ferrari, and they both drive to New York. And we tell both cars, go as fast as you possibly can. Now, the time that Ferrari gets to New York is going to be faster than that tractor trailer, meaning less latency. Now, the amount of stuff that can be carried in the trunk or the boot of the Ferrari is going to be much less than what can be carried in that tractor trailer. So now let's bring it back. IOPS, or input and output operations per second, are related to latency. How many times can you read and write to the disk per second? The Ferrari that has that fast acceleration is basically input and output operations. Throughput is the amount of stuff you can move. So tractor trailer, large amount of stuff you can move. Not the fastest thing in the world. So higher throughput on the tractor trailer, lower latency on the Ferrari. So when we deal with the types of block storage, you're going to have to pick it based upon latency, based upon throughput that you need. So the fastest block storage on the cloud, and this is brand new and it is a fortune, is EBS Provision IO2. AWS will tell you it's blazingly fast. I'll show you in a few minutes why it is not. It's the highest performance SSD storage you can buy on AWS. It's the lowest latency, meaning the highest IOPS. It's designed for workloads that require a lot of input and output operations per second, like a database. Now, here is why I say it's still slow. You can get up to 4,000 megabit per second, which is a good amount of throughput. Usually it is. And you can get up to 250,000 IOPS. Now, $250,000 IOPS, all of you can go to Best Buy, Computer Discount Warehouse, or any local computer store, and you can buy a Samsung 980 Pro, which is going to give you better storage than this for $100, 100 euros, where you're at. You get more than 250,000 IOPS, and you're going to get more than this. In the data center, it's going to cost me some money, but nothing close to what this would cost in the cloud. I can buy 19 million IOPS drive that I literally stick in a PCIe slot for my server. Can't do that on the cloud. So you got to understand on the cloud, We've got low storage performance, and we're always going to be working around it. But this is the best and the baddest and the fastest and coolest you can get with AWS. IO2. Now, about a year ago, maybe a year and a half ago, the fastest you could get was EBS Provision IOPS, which was IO1. Now, they'll still tell you it's high performance. They'll tell you it's low latency. They'll tell you it's designed for workloads for high input output, large databases. Now we're dealing with 1,000 megabit per second and 64,000 IOPS. Again, go to the local computer store, spend about $150 for an NVMe drive, and you're dealing with about 5,000 or 6,000 megabit per second, which is 6 times faster than this, and upwards of 1 million IOPS, or at least 500,000 IOPS compared to the 64,000. So now you can see why we've got storage challenges in the cloud, which we'll talk about a little bit later. They won't cover this in a certification, but I want you to know. So once you get past that, you've got some other options which are lower cost. You've got EBS general purpose SSD drives. It gives you a relatively decent balance of price and performance. It's good for the boot volume that houses your operating system because you're not going to need critical latency with that. It's not super fast in terms of IOPS, and it's also not great in terms of throughput. You get about 250,000 or 250 megabit per second with this. A traditional NVMe drive right now gives you about 6,000 megabit per second. A standard SSD hard drive, which these are built, gives you about 600 megabit a second. So this is good for a transactional workload. It's great for a development and testing environment. We're not talking any kind of performance here. Now, next, we're going to get into magnetic storage. All that was SSD storage. The first two were NVMe drives. The second one was standard SSD. Now, what if you've got move a lot of stuff, like video files? Like let's say I got a lot of videos of my cat and I want to send my video editor Manuela to edit them. So I need a lot of throughput, but the latency doesn't matter. If it takes a little longer to start the video, who cares? That's where we get into magnetic storage, which means high latency, low IOPS. Now, the funny thing is, on the EBS throughput optimized magnetic drives, we get relatively decent throughput, 500 megabit a second, which is double what we actually could get on the general purpose SSD drives. So great for throughput intensive workloads like video. Lots of data store, beautiful. But if you've got low latency requirements, this is terrible. It's great for log storage, sequential read writes, for example. And of course, here is the lowest cost version of storage, EBS cold hard drive, lowest cost, lowest IOPS, relatively low throughput at 250 megabit per second, but it's good for workloads that you don't access frequently. Chris, I want to cover how to deal with the storage performance of block storage. How much time have I spent? Should I cover RAID now, or do we need to ask questions? You're in charge, Chris.
You've gone for about 15 minutes.
Okay, then I'll cover RAID. Okay, so remember I showed you how slow block storage was compared to the kind of data center storage we have. So I also showed you, we had the concept of a link aggregation group. 10 gigabit per second, 10 gigabit per second, 10 gigabit per second. Bundle them together, 10 times 3 is 30. So now we got some speed, right? Now, we can do this with our hard drives. Now, when it comes down to this, we get into something called RAID, which is redundant array of inexpensive disks. And this is how we can create increased speed and redundancy. I'm going to cover RAID 0, RAID 1, RAID 5, and RAID 10. Now, when you deal with the enterprise, they're going to be dealing with RAID 5. But we can't do RAID 5 on the cloud because it's too slow, but I'm still going to cover it because if you're an architect and you're going to take the stuff from the data center and move it to the cloud, you better know. If you're a cloud engineer, you still need to know because you're going to be doing performance tuning. If you're a cloud admin, you probably don't need to know because they basically configure what they've been told to configure by the engineers and the architects. But the more you know, the better your career is going to be. So when we take RAID, we bundle multiple hard drives together to increase capacity, performance. Now there's lots of different kinds. let's say I want to increase my speed, right? 10 gig plus 10 gig equals 20 gig, right? That's what we're dealing with RAID 0. With RAID 0, basically take the data, write it from one drive to the next drive, next drive, the same drive, and basically double our speed. It gives us the highest capacity because we have two 2 gigabyte hard drives, we get 4 in total, and we get the speed of double. But I got these two, and I'm putting 50% of my data here and 50% of my data here. This dies, we lost everything because you can't reconstitute 50% of your data. So if you're going to use RAID 0, it's because you need maximum speed, but make sure you got backups, backups, and more backups, because I promise you, a drive will fail, and then you'll be in trouble. Now, architecturally, what does this look like? I want you to see how the data is being stored. The data is going to look like this. You're going to see, and your data is typically stored in blocks. Block 1 is stored here, block 2 is stored here, block 3 is stored here, block 4 is stored there. So what you can see you're doing is you're just sharing the hard drive, as I described, but I wanted you to get a better picture. RAID 0. Now, RAID 0 in a cloud computing environment is a little less risky than it would be in the data center because they're virtual drives versus physical drives. So they've got a little higher availability than traditional hard drives for the most part. But it's generally speaking too risky for the enterprise. Where do you see RAID 0? Video editors use it all the time. They use RAID 0 so they can edit their video, and then they store it on regular drives for long-term storage. Now let's talk about RAID 1. Ooh, RAID 1's interesting. RAID 1 is really great redundancy. So here, now we've got two different hard drives. RAID 1, RAID 0. Put the data on RAID 1, or RAID 0, copy the identical data. Data, the same data. It's called a mirror. So it's a real-time backup. I put a photo of my cat Cindy, it gets copied to the next drive, same photo. Hard drive 1 goes bad, what we do is we call break the mirror, and we work off of the second hard drive. But we don't get any speed, and we don't get any enhanced storage. It's slow, because it's one drive. It's expensive, and it's the lowest capacity too, but it gives us lots and lots of it. So architecturally, what's it look like? I know I kind of tried to show it with the pens, but I want to show you now. Now we've got the same data being replicated to the two drives. Kind of keep that in the back of your mind. Now you get it, now you know. Now, let's talk about RAID 5. RAID 5 is used everywhere. Now, RAID, we can't use it in the cloud. So RAID 5 provides a combination of speed and redundancy. RAID 5 requires a combination of at least 3 drives, just like we got here. And what it does is it writes data to all drives, and it adds backup data to all drives as well. You walk into an enterprise, they've got some flavor of RAID 5, RAID 5, RAID 6, RAID 50, RAID 60. It's basically some flavoration of those. So here's what you can see. If you look at how this actually works, note we've got 4 hard drives here. So how much capacity do we have? 3 out of 4. What does this mean? I copy one block to hard drive A, the next block to hard drive B, the next block to hard drive C, and then I add this parity or backup data. And then the next time I store data on hard drive 1, store data on hard drive 2, put my backup data on hard drive 3, and then the 4th. So what you can see is every drive has backup data and primary data. Now, if any one of these disks fails, all we have to do is as follows. We pop a blank, empty disk, and the backup data from all those drives gets reconstituted into real data, and we are backing up and operational. Now, why can't we use it in the AWS Cloud? Why won't they let us, given that all businesses do? The process of writing that backup data adds latency. And when you're dealing with hard drives that have basically high latency, low input and output operations per second, like block storage, do we really want to put ourselves in the position where we've got to add additional lanes? And the answer is no, and that's why AWS will not allow you. So now we're going to get into what do you do if you need to boost your speed, but you can't be reckless with your redundancy. Now we're getting into RAID 10. So let's talk about RAID 10. RAID 0 and RAID 1 put together. Remember, RAID 0, data is maximum speed. Just stripe your data across all drives. RAID 1 is a mirror. So what RAID 10 is, we create RAID 0 arrays, and then we create a mirror image of that. That gives us the highest speed, the highest redundancy, and it's becoming increasingly popular, but it's the most expensive. So let's look at how we did this here. As you can see, we created a RAID 0 environment where we're striping our data, block 1, block 2, block 3, block 4, block 5, block 6, block 7, block 8, on one. And then on the other one, it's copying the next RAID 0, everything that we put on the first hard drive. So hard drives 1 and 2 look like one drive, super fast. Hard drives 3 and 4 mirror that hard drive. So I think that's a good place to stop and take some questions. So if you haven't liked or subscribed, please do so. And then Chris will collect some questions, but I got a special BGP coming for you, so please follow us on LinkedIn. What are the encryption options for AWS for S3? I know you can do, what do you call it? I think it's AES 256-bit. But I would check on the AWS website because it changed constantly. What's the storage between block storage and blob storage? Block storage is block storage. Blob storage is object storage. So think of block storage as more of an Azure managed disk. Think of S3 as identical to blob, which is also identical to Google Cloud Storage. Good questions. Are those storages volatile or non-volatile? All block storage and object storage is non-volatile. Storing stuff on the system itself is volatile or ephemeral. Good question. Are snapshots in the sense of cloud similar to the way we do with backup and replication software? Mostly referring to, no, there's the exact opposite. So typically with backup software, you basically have the option to store and back up the operating system in every single files, but they're copied independently. A snapshot is more like semantic ghost or imaging software that you would take something, you would create a single image that's inclusive of everything, and you can restore the entire machine from the single image. That's exactly the difference. Is parity data like metadata? No. Metadata is data about the data. My cat Cindy is chasing her tail. That's metadata. I got a picture of our video of my cat chasing her tail. Metadata is telling me that. Parity data is actually backup data. So if the data is lost, we can recreate the data. So completely different, but great question, Clyde. Can RAID be used to optimize data access? That's why it's used, to increase speed and performance. So in other words, if your hard drives are too slow, bundle multiple of them together. Or when you need more storage than a hard drive. For example, in my office here, I've got a 96 terabyte RAID array. And what is that? It's 12 8 terabyte drives. Why did I do that? Well, I can buy an 8 terabyte drive itself for like $200. But if I was to try and buy a 96 terabyte drive, I wouldn't be able to buy it. And if I did, it might be $30,000. So that's why we do RAID. Is there a minimum number of disks for RAID 1? Yeah, minimum is 2. And that would be the minimum for RAID 10 would be 4. Tech Electric, why exactly the RAID and why do we need to use that? Well, if you need to increase the capacity beyond the capacity that you could buy in a disk, you have to use RAID. So let's say you can buy a 40 terabyte hard drive. What happens when you want to use a 40,000 terabyte hard drive? You got to bundle multiple hard drives together, hence RAID. But in the cloud, I showed you how slow their elastic block storage was. But what if you need more of it? That's when you're dealing with RAID. so that you can add multiple speeds together. So having 2 wires that are each 10 gigabyte gives you 20. That's why we're using RAID, the same things. We can bundle the speed and bundle the capacity. So do you need to know RAID on the essay exam? No, but if you want to work anywhere, you're going to have to understand it. And you will need it for the professional. I'm giving you additional info because, let's face it, what you need to know for the exam is not enough to get you anything in life. And I want to give you the options to have a better career. Explain. Private cloud storage means storage in your data center. Public cloud storage means storage in somebody else's data center. I have no idea what you mean by community cloud storage. And hybrid cloud storage is more of a slang term, so I don't exactly know what you mean by that. But it could be if you want to know what a hybrid cloud storage is, truly, it's because you're running a hybrid cloud, and some of it's you might have 50% in your Nutanix data center or OpenStack data center and 50% in AWS Cloud. That would be hybrid cloud, and your storage would be like, but community, I don't know what you mean. How is the snapshot size compared to what it copies? I believe it's the same size, but you can run a compression algorithm to make it smaller if you desire to as well in most data center environments. What's the difference between EBS? We just talked about it. It's block storage, which gets mounted to the computer. And we talked about object storage. We're going to cover file storage, which is file storage. EFS is just file storage. If you guys can give me a hashtag AWS training. And for the person who asked about networking basics, we have a completely free CCNA course on our YouTube channel, and someone will be able to use that. Let's cover the elastic file system. And I don't see enough of the hashtag AWS training, so please make sure you give me a hashtag AWS training. I'd like to see a couple hundred of them in the chat box so that I know that you're here. So, as we talked about, object storage is a means to store your data for software backup, archival purposes, distribution of content, etc. We talked about block storage being something that you mount into the system itself, like a virtual hard drive. But what if you want to access your data over a network? Let's say you've got 50 users that need to access the same data, right? File storage. You've got, and you can do it with Windows or Linux systems. With Windows systems, maybe you create a share of your C drive. With Linux systems, somebody creates an NFS share. So what is Elastic File Service, Serge? It's simply an NFS share for you that you don't have to manage. Now, you don't need to use this at all. You could create a virtual machine, use block storage and share it and create an NFS share. And all your systems could access the same data. And that's what we do in our data centers. We basically share a file, or we share a folder in NFS and all of our Linux and Unix systems. But one of the things people like in cloud computing, one of the things I don't like, is they have all the access to these managed services where somebody else does it for you. Kind of like when you go to McDonald's and you say, I'd like a hamburger, and they say, would you like fries with that? That's a managed service. Compared to if you went to Morton's and you said, I want a hamburger made for me, and I want prime beef, and I want this, they can do it for you. Managed service, done for you, basics, self-managed, access to everything. Now you see what we're dealing with. So if you don't want to manage your storage environment, AWS has a managed Linux and Unix service for you called NFS. And of course, with everything else, you've got our standard, our highest performance option, our infrequent access for files that you don't use frequently. We also have two options. One is called burstable. What is burstable? You get access to a certain speed, but if you go above it for a little while, you can use it if the capacity is there. Whereas this provision and throughput is, I want to guarantee that I have access to this much information. So if you, and this could be a text question, you need POSIX compatible storage. What do you need? You need NFS or EFS. So Elastic File Storage is just the way AWS rebranded Sun Microsystems, now Oracle's Linux, Unix, NFS. Same tech, 40 years old, renamed Elastic File Storage. Now, the Elastic File Storage is scalable, which is, it's got relatively good throughput, relatively decent latency, relative, on the scheme of things. And one thing that I do like is the sizing automatically adjusts. So if any of you guys are used to the way I normally do stuff in the data center, we'd have to do capacity planning. We'd see that we've got to share, the hard drives are running low, and we'd have to do something about it. Now, here, it just scales automatically for you. So that is a very nice reason. So Unix and Linux systems is what we're dealing with the Elastic File System. Why? It's just a managed NFS environment. It's going to look like something like this. So from an architectural perspective, instead of you having a server, you got the Amazon managed storage server. Your system's all mounted, and they can look at the same information at the same time. So what if you had Windows instead of Linux? NFS doesn't work on Windows. It works on Linux and Unix. So Amazon's got a solution for that. Now, of course, you could just build your own Windows file server and share a folder like we've been doing for decades in the data center. But if you don't want to build a Windows server and you don't want to manage the Windows server, guess what? We got a solution for that too. And that's called Amazon FSx for Windows. It's a fully managed, high availability Windows file system. It uses, guess what? It's Windows, the server message block protocol. So what do you think this is? Amazon runs Windows servers, and they give you space on their servers. So if you need Microsoft workloads and you want to deal with quotas and Active Directory, this is going to support it. Why? It's just AWS running a Microsoft Windows server for you. And it provides encryption in transit and at rest for you. So how do you use it? You create a file system, you configure your shares, and you run your applications. No different than you would with any other Windows file system that you would use. And then we have Amazon FSx for Lustre, which is an ultra high performance file system that can give you millions of IOPS and hundreds of gigabits per second of throughput, can be synchronized bidirectionally, and can be synchronized with multiple buckets. And this is what you use when you need high performance. So I keep that in the back of your mind. Okay, so we covered block storage, object storage, file storage, instance storage. So you got your data in your data center. You bring in the data to the cloud. How are you going to get it there? Well, we got a couple options, because most of what we do is migration, because we take stuff out of a physical data center, move it to the cloud, which is a virtual data center. Same thing, nothing's different. Like the Who song, meet the new boss, same as the old boss. So let's talk about how you send your data to the cloud. Now, there's lots of ways to do it. One of the easiest ways to do it is with something called the storage gateway. And a storage gateway is a virtual machine. Amazon likes to call it an appliance because it feels really exciting that way. And it's a virtual machine you put in your data center. You either stick it on one of your VMware servers or one of your Microsoft Hyper-V servers. And storage gateways can do a lot of really cool stuff. I absolutely love these. You can use them to get your data to the cloud, or you can use them for recovery and backup purposes. And they're beautiful hybrid clouds as well. And when we get with regards to storage gateways, we've got a couple of them. And we're going to cover the file gateway, the VM gateway stored mode, the VM gateway cache mode. We'll talk about how we can do things over the iSCSI protocol. We'll talk about caching and files from S3, tape gateways, and backing up to S3. So let's first begin with a file gateway. Basically, here's what you do. You set up the virtual machine and it acts like a file server. You put it in your data center. You connect all your stuff to this file server. And it will support server message block if you've got Windows clients and NFS if you've got Linux clients. You copy your data to your local file server sitting in your data center, and then your data gets just magically copied over to AWS S3 object storage. And they'll become objects on S3, and they'll be encrypted with Amazon server-side encryption SSE-S3, which we talked about before. Here's what it looks like. We've got our application servers. Connect, for example, sending data to the storage gateway. Over the direct connection, it goes to AWS S3. And of course, you can run a lifecycle policy management, which we did here, S3 and frequent access and Glacier. It's your typical basic storage gateway. But there's different ways we may want to use a hybrid cloud environment. So let's talk about the volume gateway storage mode. Now, if you want to keep your data in your data center and you want to back it up to the cloud, now we're talking with the volume gateway storage mode. And what happens is this will automatically asynchronously, over the speed of your network, copy your data to the cloud. And basically, it's going to take your data and back it up as an EBS snapshot on S3. Basically, what happened is you install the storage gateway. You create your storage volumes on the gateway. Your devices mount to it via the iSCSI protocol. And your data is copied over to the cloud. So let's look at what this typically looks like. Here's your data center. You got all your servers. They connect to this volume gateway, which you can see where it says hypervisor, which is it's the host is your server. The hypervisors like your VMware or Hyper-V. And then these are your virtual machines, your volume gateway. So your systems copy it over to the virtual machine, and it backs it up on AWS. This is what you use ideally if most of your data is in the cloud. Now, what if you want to have a data center, but you want to store your data in the cloud? Now you need something different. So that's where you can use volume gateway cache mode. And it's designed for organizations who keep their data primarily in S3. It makes the data stored in S3 feel like local storage. Same thing, you install the storage gateway. The devices mount to the gateway via iSCSI. Data is retrieved and cached from S3, so frequently access is kept locally. All data on S3 is encrypted. So kind of keep that in the back of your mind. So what's this going to look like? It's going to look like this. This particular environment, we've got our data. We connect on our users. We connect it to the volume gateway. And from there, our information is stored on the cloud. So let's look at how this actually works, because this is pretty cool. If our data centers in the cloud, so we've got a user that requests data over here. The request goes to the cloud. Now, hold on. Now the cloud takes the request, it sends the data. And it sends the data to this volume gateway. And it caches the data. And then it sends it to the user. Now the next host that wants to receive the same data sends a request to the local volume gateway. It's already stored on the volume gateway, and the data is then sent back to the person. So for an organization that wants to use the benefits of cloud storage, which is often cheaper than the data center storage, they can actually use the cloud storage, and they can use this volume gateway as a means to translate object storage, which computers can't mount, into file storage that the local computers can do. So that's another way to get your data to the cloud. Now that's what you're going to use if you've got a good network connection. But what if you don't have a good network connection? Well, we got to get our data there somehow. So now we get into some pretty cool options. The first option we're going to talk about is the Snowball. What's a Snowball? It's a ruggedized computer that's filled with hard drives in a RAID environment. And a Snowball is typically 80 terabytes, which gives you 72 terabytes of usable storage. Remember that, 80 terabytes, 70 terabytes, 2 terabytes of usable storage after formatting. Looks like a test question. It's got high-speed networking, 10 gigabit. You copy your data onto the Snowball, and then you ship the Snowball to Amazon, and they copy it to S3. So what does this look like? You request a Snowball. Amazon delivers the Snowball. You put your data on the Snowball, and then your data is loaded onto S3. Great environment. So if a Snowball gives you the ability to send moderate amounts of data, so if you've got, say, 250 terabytes of data, you get 4 Snowballs. There you go. But what if you got a lot of data? Well, what if you want to move like a bank's data center? Well, now you're getting into some serious data. And if you have plenty of time to do it, you can do it over a couple of 10 gig connections. But if you don't, this is where the Snowmobile comes in. This is the coolest thing ever. So basically what happens is it's a giant shipping container filled with servers and storage, 100 petabytes. It's data center on wheels. The thing is shipped to you, usually on a tractor trailer. You copy your data to this data center locally over your high-speed network, and then somebody drives the Snowball, which is basically a shipping container attached to a tractor trailer, back to AWS, and AWS personnel copy it. So I always thought that was kind of a cool way of doing things. So now let's get us into the import-export service. So we talked about the Snowball, which is basically some high-capacity mini computers that are shipped to you. We talked about the Snowmobile, which is basically a tractor trailer full of storage that's shipped to you. Now let's talk about the import-export service. This is a simple storage environment. Basically speaking, it's basically a rental hard drive. You copy your data to the rental hard drive and you ship it to AWS, and it goes, ships to AWS, and AWS copies it onto object storage, otherwise known as S3 for you. So let's talk a little bit about Amazon Workdocs. Amazon Workdocs is a fully managed content creation collaboration service, kind of like Google Drive or Dropbox. It enables businesses and people to collaborate on creative projects, share documents together. It's simple and affordable, and it can be accessed via the web or mobile client software. It works with Windows and Mac OS clients, and it means typically all industry standards, HIPAA, PCI, ISO. So what did we cover in this section? We talked about the types of storage, block, objects, and file, specifically AWS S3, EBS. We talked about RAID, or redundant arrays of inexpensive disks. We talked about the Elastic File System, which is just AWS branded network file system. We talked about the file system for Windows and the file system for Lustre for Windows. And we talked about storage gateways, Snowmobiles, Snowballs, import-export service, and Amazon Workdocs. Let me see if anybody has any questions.
All right, so let's get to the questions. Are we going to be doing any more content after these questions, Mike?
Not today.
All right.
We're probably going to run 1 or 2 days extra late, so we don't have to do Saturday, but today we're going to finish here. We covered a tremendous amount of content. We got a really great show tonight on interviewing.
All right, give me just a second to get these questions pulled up. This one is one that I missed the first time around on the last section. So give me just a second. I gotta scroll back and find it.
Will you be charged for the incomplete files uploaded? Well, not really. They're going to be recharged. So it's weird the way AWS charges you. They don't charge you to put your stuff on there. They charge you to get it out. So you don't typically pay for uploads, just downloads. Good question. Because they want your stuff there, but they don't. But if you pull your stuff, that's where you pay. Is there a reason that EFS only supports Linux? Yes, the network file system is only for Linux systems. It's the way Sun Microsystems invented it 40 years ago to work with Linux and Unix systems, and that's why it doesn't work with Windows. Although I suppose if you installed the Windows subsystem for Linux, which is basically a Linux kernel, you could possibly get away with it, but I've never tried it. But no, Windows uses server message block, Linux uses NFS. Object file and block storage are all non-volatile storage. They don't go away. They're not ephemeral. Is FSS for Lustre only for Windows? I don't believe so. It's for high-performance computing. S3 is object storage. S3 is replicated in the RAID is replicated exactly the same way that block storage volumes are replicated. Guess let's go to the next one. You could also use local zones to ship your data from AWS to Snowball if you were going to store your data only on the local zone. But if you were to put it on the local zone, you're going to have to pay to get it back to the actual cloud. So I wouldn't do that at all. You can actually send your data to Glacier directly. Same time tomorrow? Yes, absolutely. Same time tomorrow. Is there a use case for FSX? Yeah. EFS, remember, all these storage environments are low performance. Block storage is slow. The elastic file system is not fast. Lustre is designed when you need really high performance storage in the cloud. Well, learned a lot. Thanks for the cloud. I'm so happy to hear that. You're more than welcome, Eaton. Do you need strong knowledge of Linux or NFS? Well, you definitely need strong knowledge of, you need to understand, it depends on your job. So if you are an architect, you need to understand how the Linux kernel works, but you don't need to know how to touch the technology, because as an architect, you won't touch the technology, which is why projects don't work for architects. Design projects work for architects. But if you're an engineer, you're going to need to know how to configure Linux. And if you're a sysadmin or a cloud admin, you're going to need to know a lot about Linux. So it all depends on the job. Each job has a completely different skill set. Same reason a doctor and a nurse go to different training. Cloud architects and engineers need completely different training. For transferring huge amounts of data from the data center, how to use a storage gateway. As we described, what you're going to do is you're going to copy your data to the storage gateway, and it's going to asynchronously copy it over your direct connection or VPN to the cloud. I think I understood your question. Awesome boot camps. Thanks, Mike Gibb, the Go Cloud Architect. Thank you so much, Frank. I'm so happy to hear that. Can you plain explain instant storage again? Absolutely. You got a virtual machine, and it's got its hard drive that's attached to it. It's the hard drive that is actually in the physical server. It is much faster than any other storage, but if you terminate the instance, it completely goes away. That's why we can't use it. Excellent, Christo. Thanks, Mike. You're the best. I was going to say F had a stow because the way you wrote Christo, you may understand that, but thank you very much. So is RAID technology used in multi-part uploads? They're completely unrelated. Multi-part uploads are you can send your data in little pieces to the cloud. RAID is a way to increase your disk performance and capacity. So they're not related. Is it normal to feel a little overwhelmed on the first day? Absolutely, yes. If you don't have a networking and a data center background, it'll be very overwhelming. If you don't, but here's the good news, we covered a lot of it, and you can watch it again and again and again. We're going to leave it on YouTube completely free for you, and read the book. We have a completely free book, which we attach for you that you can get in the description of the video. My team will put it in there. You can read it on your own time, and at that book, the exam guide is really going to help you. Tetra, good time to spend here. Thanks, Mike. I'm so thrilled you're here. Thank you so much, Florence. Thank you, Mike. So thankful, Gressland, to have you here. Thanks, Mike, and the teammates. Excellent journey. Wellness, yes, thank you to the teammates. There are people all over the world. We've got Eddie in Cameroon. We've got Tyrone, who's in South Africa. We got Chris and Alonzo in Florida and Texas. Lots of people behind the scenes. Thanks, Igor. We're thrilled to have you today. And yes, I want you all cloud hired. Thanks, Mike. Super information. Jason Anderson, good to see you. So nice to see you. We are so happy to help any way we can. And Tracy Downs, you're excited to take this journey. We're excited to be here for you. Chris Backlow, great stuff. Thank you. So I love doing these boot camps. That's Alonzo from my team. If you guys can just give me one last hashtag and give me a hashtag AWS Solution Architect certification as a hashtag. I love knowing that way you're here. Tomorrow we're going to start at the same 12 p.m. Tonight, we're actually going to hold a special show of Head in the Clouds at 6 p.m. Eastern on the same channel. And we're going to be talking about how to get hired in the down economy like we're in now. I want everyone in the world to have the absolute best cloud computing career that desires it. We've got a lot of stuff, so please do that. Also, we're going to do a free BGP session for you. And I may have a surprise BGP document that'll change so many things for so many of you. So please follow us on LinkedIn because we're going to be distributing all that stuff on LinkedIn. Please like, subscribe, and hit the bell notification so you don't miss on any of the great things we're doing in the next few days. Now, everyone, goodbye. I enjoyed spending the afternoon with you, and I look forward to seeing you all tomorrow.